Okay, good morning, good afternoon, good evening, everyone. Welcome, folks, today. Hey, Tor. Hey, Marcus. Hey, Scope. Martin and James and Steve. Hey, Arthur. Hey, Tuxedo. Hey, John. Hey, Jeff. Hey, Bill. Tuxedo and Derek and Malfrey. Hey, Demlar. How you doing, Marcus? Andres. Hey, Kevin or Just K. What else do we have? Maurice. Fabrico. How are folks? Back on Blackbox today. Hey, Poity. Hey, Bruno. Brian and Kusuria. Hey, Lewis and Lucas. Hey, Turtle. Hey, Sebastian. I am working in probably the cleanest this garage has been in a long time. So I am feeling pretty decent about it. Hey, Ella, Rod, Dexter, Derek, thanks for the gifted memberships. Welcome new members. This Saturday, I'm hoping to do, well, I need to. This Saturday will be the member stream. Phoenix is over there, off camera. Hey, Stefan. Yeah, I can tell, good stuff. Hey, Guy the Jedi. Yeah, so the new thing is this. Not super happy with it, but I'm hoping I can make it work. It's a big 8-foot by 3-foot deep maple butcher block work surface. It was delivered on Friday. I'll need to work with the company on it. So hopefully I can make it work. Zero G. Coffee Squirrel and Dutch Dude. So we got Dutch Dude and Zero G. Different people, right? Stefan and Dave. What else do we have? Jeff. But what it does mean in even the short term is I have a spot for Milo. So I can use the Shapeoko and the Milo, not at the same time, but without having to rearrange things, because I'd been using the Milo sitting on top of the Shapeoko. I did make some things this weekend on the Shapeoko. I made these. Modeled these up in CAD and used Fusion Cam. I saw your message. You're out herding cattle. That's awesome. You have a lot of shelf space on those walls. Yeah, there might be some bikes going to hang right there. I need a spot for those. Old account. Hey, Reth. Simon. Andrew. So what this is filament rack. So conduit similar to a rep rack. It's going to hang in here. Just kind of drops into there. And this is going to bolt between two walls. Two walls that are only about this far apart. And I'm going to run them there. And in the spot where this is going to go, this is going to make room for like 80 rolls of filament. So that was yesterday's project. So Bob at I Like to Make Stuff, his recent videos on point for arranging spaces and figuring out critical paths and constraints. And my critical path right now, I think, is moving this setup to that wall. So that's what I'm working towards, doing that. So what's wrong with the workbench? The maple butcher block top, I think, is subpar on the quality. I think the filler that they use to fill in any imperfections, there are going to be imperfections. There's no way around that with a natural wood top. The filler they used is garbage. It came out with a soft toothbrush, kind of rubbing over stuff, kind of checking for things. It did not harden, basically. So I'm gonna have to put in some work to fix the top. The whole thing is wobbly. It says it's got a 5,000 pound load rating. There's no possible way. I know that that probably means 2,500 pounds over each leg on each end and put nothing in the middle, but it wiggles way too easily. So it's not. I'm hoping I can fix it. I'm going to be talking to the company about what they can do about it, basically. So, bar opening if there's a wall behind it. Figure out first order of access, everything drives from there, yeah. Can't hang out today. Hey, Pathetic Puma. Daughter's dance recitals, have fun. Hey, Biney. It is wobbly, so I'm gonna put some cross braces behind it. Gonna leave the front open. I'm gonna make a better platform where there's you can kind of see that chrome bar down there. That's supposed to be a footrest. I'm gonna make a platform that bolts across the whole thing so I can put a shelf there, and that'll be like where the diode laser goes and stuff like that. I'm hoping I can make it work. It just was way too much money for how much work I'm gonna have to put into it. I don't need another freaking project. And I could bolt it to the wall, and I may, but I need it to be stable without that. It needs bracing in the middle. I bought it with that load rating because it didn't have bracing, and I would have a full open bottom. To properly stabilize it, I may have to put bracing. I don't know. But I will be putting some angled bracing in. Going to make a video on the new filament rack? I did. I took some video. Don't knock it. Hey, TT. I took some video. I had mentioned it before. I got a new camera. John's not here, right? I got a new camera, and I was really pleased. It was kind of neat. I got one of those Osmo cameras, and I set this up on a tripod and pointed it at the tool head and set in a little interface to follow the cutting head on the Shapeoko. And I did a cut of one of those, and it was kind of cool. It followed it along as it was doing its cut. So we'll see how that turns out. So I've got one more to cut. I'm going to take some video of that in a slightly different angle, different way, see how that turns out. So, I'll tell him. You doing non-live videos now? I'm not promising anything, that GPs. I've released one video. I have lots of ideas for videos, but I'm actually starting to feel like the place is starting to come together, and I'm tired of, I'm anxious. I'm not tired of, but I'm anxious to have the place together so I'm not constantly working on the space. I can start working on projects. It'll follow you as a webcam too. Oh yeah, I've played with that. I thought about trying it and setting it up for this video, so then when I shift around, it'll follow me. So we'll see. I tried it, may make its first moves by the end of the stream. Awesome. What are those MDF plates for? It's for a filament rack for the other garage space. I like my shorts. What brand are they? I have no idea. The dead sun and the rotation on the Pocket 3 is my only gripe. It can be worked around. I haven't used it enough to see that. Need everyone's thoughts and prayers. What else? We need to get into this. We've got a lot to do. In cleaning up and organizing, I did find a neat thing that some of you might think is interesting. So I inherited all my dad's tool, well, some of my dad's tools. My brother got much of the tools. But I was going through this old Cornwell toolbox that's over here, and I found this guy, which is kind of really neat. It's the LSS company. So let's stare it. It's a little stare it with 64ths and 32nds. On the other side, I've cleaned off some rust on it. 16ths and 8ths. Really neat little imperial ruler. Hey, Timor. Left corner, original Osmo was 1.5 turns, new one is under 360. Oh, I don't know. So, yeah. Got a neat little thing in there. I was wondering what the LSS company is, and when it came up, it comes up to Starrett's website now, so. That's right. Thanks, Garrett. So we have 2 giveaways today. We're giving away our usual Polymaker filament giveaway, and then Garrett's got To the Moon Spicy Hot Sauce Harvest Edition. 1 bottle of that to give away worldwide. And it's also 50% off on the website right now if you want to try it anyway. Okay, what else? Original Pocket 3, only 6-year difference. What else? What else? Oh yeah, I've been working on. So the days of me running back and forth between the garages for fasteners is over. I have my fasteners. Not done organizing, but it is well underway. So here, maybe this will be a better view. Yeah, let's go. Make sure we stay down. Yeah, there we are. So I've even started labeling them. Now they're not really organized in the where everything is going, but yeah, it's no longer temporary napping. It got easier when I realized I'm not going to be able to move back to the other garage and really be able to do what I want to do. So what I need to do to make this space work is all the tools that create dust. I need to reduce the amount of dust that create. So I need to up my dust management game. They are printed with a labeling machine, and I actually created an Excel file and used the Brother software to bring it in, and I printed most of these all in one go. So, but what helped me get past some of the details, getting caught in the details on these, is no longer, I don't put the size that's in that bin. I've got M3 button head stainless steel for these 4 bins. I don't really need to know exactly which size is in which one. If I'm looking for an M3 by 8, I know it's going to be in this first bin. If I'm looking for a 20, then I know it's going to be in one of the 2 middle bins. Is better in this garage. Use a temporary solution long enough, it becomes a permanent solution. Yep. So simplifying, and this also makes it more flexible. So if I suddenly get a new size of fastener, I can just shift them around in the bins and not have to relabel them. So yeah, I can share that, Arthur. It's actually a Google Sheet that I export to a Excel or a CSV file actually. And then the Brother software can bring it in. It's not finished. All I did was the M5 stuff. I'm going to put like washers and hex nuts, and these haven't been relabeled, but all of these down here are all T-nuts of some sort. So M5, M4, and then M3. So, it's a good idea. I did the same for my bins. I put the size labels on the liner dividers tabs. Yeah, I figure I can tell looking at something if it's the right size, or I can pull out my ruler. Arthur, you will need to poke me in my Discord for me to remember that. So, I'm great to have all that all at hand. Yeah, right here. I've got a bunch of other stuff. This is all going to transfer to when I move to this wall. So one thing I need to do over there is I need to run a network cable though. So I have power over there. I have a 20 amp circuit on that wall. I need to run a network cable. So, and then I'll be closer to be able to move over there. This is a 4-foot deep workbench, and that I can't reach from right here. I can't reach that camera to turn it on and off. I have to go around the side. I won't be able to go around the side over there. So I'm building a little trolley system that's already done. I just need to mount it. But a little trolley system so I can pull the camera closer and reach up and hit the power. Modbot's already getting a bit messy in his new place. He'll get there. He'll get there. Okay, we are on Blackbox. So we are on guide 6. And I feel like we're doing pretty good for being the 4th. This is the 4th stream in the series. We're on guide 6. We're going to be building the tool docks. Last stream, we built the carriage. And there are a couple of things that I noticed that I'm going to need to fix, or at least look into to see if I need to fix. I've been looking into doing something like that and found the Screwfinity. I'm going to use that once I've finished making my tweaks. Awesome. Let me go over what I haven't fixed from last stream, but I'm going to need to fix. So let's bring this up. This isn't going to be the greatest of views. Maybe I can turn this around and get the other camera. I'm looking into doing something like that. Oh yeah. Okay. Let's go here and here. Okay. On the tool head here, we spent all this time making the pins for this little kinematic mount setup. Epoxying those into this plate. The one that was the most difficult is perfect. There's nothing I need to mess with on this side. I used my Kinepix pliers to push those in all the way. Epoxy is there, they are not coming out. On this side, I've noticed that these are a little more proud of the surface than these are. I don't know if that's intentional or not. I need to check. I need to look at the CAD. I need to see how much these should be sticking out. What I'm afraid of, and I need to figure out, is if these didn't seat all the way when I was gluing them, I'm gonna need to pop those out, scrape out the epoxy, and re-glue them. Hey Skyrim, hey Yontech. I'm guessing that they need to be even. And by feel, I can tell that these are more proud of the surface than this. So I'm going to look into that more closely, and I'm going to fix that in another in between streams. I meant to do that this week, but I got caught up in all this cleaning and stuff and kind of forgot about it. So that is a thing. And then if you look at the orientation of these steppers, so Poity, pay attention here. I'm pretty sure we spent a ton of time making sure that I was following the directions for what orientation of the wires coming out of these steppers. The problem is, and we're gonna have to fix this, is when the bed gets there, yep, see that? Now it will push back without actually damaging the wires, but long term, that's not okay, because the bed's gonna spend most of its time up in this range. Oop. Had the camera box holding the bed up. So these are facing each other, but the bed is hitting. I mean, there's not room for that connector. So I'm going to between streams. I'm not going to do it on stream. Because it may require me partially undoing the belt setup. I'm going to rotate these to where it's facing this way. So something to note for the manual. These are, there we go. So yeah, they need moved. And I just noticed this last night or yesterday when I was doing the thumbnail for the stream. I wanted to move the bed up so I got a better picture of stuff. So it would be, the distances would be better. And I noticed that was not great. I am going to oh shoot. I'm gonna put a bed surface on here, and I know that my the one that came with the printer is buried, so I am going to grab another 300 plate that I have. Yeah, so I can stop worrying about scratching that up. There we go. Doesn't it fit the other way? Cables in the V slot. No, because there's a T-nut there, and I would need to do some weird routing. It would be better to come out this way and then down and into the T slot, I think. Yeah, there's a T slot nut in there that would prevent it from running through there. What 48-volt power supply do you recommend for Kraken? Boy, what, I mean, that depends on how many steppers you're running, what you're doing. Anything not morn sun right now, right? Because you're not going to be able to get them. Make them face the tool dock. Yeah. Okay, let me move this out of the, I don't know if we're gonna need this, but I'm gonna move it out of the way for a minute. I need my workout, so we'll move it back and forth a bunch of times. Hey Sven. What are you trying to power there, Tohos? With the Kraken. I mean, it's still just for steppers, but. Hi, Joel and Brent. Okay, here are the instructions. We are going to be building the tool docks. And I'm hoping, so the hope is to get through all the tool docks and through at least one tool head. And then I'll probably do the other tool heads off camera. So we'll see how that goes. Four steppers at 48 volts, but what steppers? Are they NEMA 23s? Are they big NEMA 17s? Not sure if you saw Modbot stream. Big shout out to him pausing the build as he felt the PSU was unsafe and going for an external PSU instead. Yeah. I think for a DIY machine like that, your power supply probably should be self-contained. You should not rely on the build. I think he made the right call there. I think there's a definite decision by the community who is designing that printer to make everything inside of the printer. But at a certain point, you need to consider your audience and your builders. Hey, Danny. Okay. Oh, we are going to need more epoxy or CA glue. And we got a bunch of parts. So let's just get into the instructions here. And I think we're starting to get into, we are getting into the updated instructions, at least for pictures, screenshots, because look, we can actually see what's there. Hey Bob, welcome. Look at that. There's some contrast. Oh, I didn't do heat sets. Oh, darn. I guess we get to do heat sets on stream. See, I had a busy, I got distracted with other projects, so. Thank you, Matt. Okay, do not over tighten. So this is all the words still. It's just updated pictures and probably a few tweaks. Locate the tool dock printed parts shown below. Using an M3 tap to create threads at these two locations. Be sure to tap all the way down into the 4mm bores where they intersect. And then we have a bunch of heat sets. So let me get, I think we're doing all, I'm hoping we're doing all M3s. So let me get this started and find my tap, which is over in the Cornwell tool chest here, which has, it's stacked with Nerf blasters or foam dart blasters right now. Okay. Oops. M3 tap. This new YouTube layout, can't even see where to give a thumbs up. Wow, if everybody can look and find out, see if you can find that thumbs up button, that like button, or dislike, whatever. Let's see what we can hit today. Hey Taylor, won't be able to stay for the whole stream, but want to jump in and say hi to everyone. Hi. Okay, so we have a bunch of these. Let me grab these and we'll just kind of batch them out. I am a little disappointed I didn't get to these because this is going to be a significant amount of time. Found it? Nice. Guess we're gonna go here. Just gonna go through and do a bunch of, oh, that needs to tap a long ways. You know what? Let's grab, a little bit of a mess under here. We're gonna speed this up a bit. Let's turn this down on speed. Put this in here. And we will do this slowly, but this will save me a lot of strain. Don't jump in streams and get your socks wet. How you doing, Bob? You gonna be at Murph? This and this, and I am really sorry for not doing this pre-stream. I forgot that this kind of thing would be needed. Hey, Lutian. Still trying for Earth? Okay. I'm not going to Earth. I'm going to 3D Printopia. One done. Two down. Went to Protopasta yesterday and made filament. Nice. One day I would love to get up there. Did you make your own blend? Is that how that works? Or how do they work that? Three. Yep, got to mix my own color. What'd you go with? I'm pushing the speed on this probably a bit, but it is ABS. I'm hoping it can handle it. And it's just for grub screws. It'll be fine. If it gets a little hot and goobers the thread, it just gives more for the grub screw to stick, right? Okay. Oh, no, one more. One more. Dark red with black glitter and a bit of gold pearl. Ooh. Ooh. A flying pancake, I have not tried those, so I can't make any recommendation. I don't have much tool changer experience at all, so I don't know. Okay, now we're gonna put this and heat sets. This over here. Oh, let's go in a bit. There we are. Oh, we'll use this guy. And are we, oh, we're focusing on that. Maybe this would be the better camera. Yeah, that'll look better. No reamers for this job? Oh, there may be reamers. Let's see, we did the tapped holes. Now we need to insert a bunch of heat sets each. And then a 5x10 magnet goes there. Note that we'll be repeating these steps to build up all 5 tool docks. It's important to keep the polarity of the magnets in a consistent direction during assembly. This will keep you from tool docking issues later in the build. For now, we only need to ensure that the polarity is consistent across all docks. Sure each magnet is fully seated into the printed block. Once installed and seated, the magnet should have a snug fit, since there's no retention mechanism other than a friction fit for these magnets. Can be used to further secure them in case of a loose fit. U-block origin. I gotta keep working on my micron. I haven't touched in about a month. What color you choose to make? What color for what? Giveaways are international. Yes, both giveaways are international. I need my little 4mm reamer. You're right, because the holes on these parts are a little small. On later parts of the build, I realized that and started modifying the files to fit better. But on these, they could use a little bit of reaming. Michael. Okay, so we are gonna go and just do a little bit of Are we going either side there? Yeah, there's heat sets going all the way through here. So I'm just gonna bring this all the way through. And then these guys. And is that it? Yeah, that's it. Hey, Big Red. If I had a 4.5 millimeter reamer, that'd be better, but this will be okay. Oh, what do we got? Hey, Takuya. Hey, Takuya, you would tag me in that channel that you have, and I keep forgetting to respond. We'll chat about that later. Okay, where are we at? Now we got to do a bunch of heat sets. Up away. Then the other side, just give a little more stable surface. Oh, it almost fits in between the 1, 2, 3 block. This way. If I wonder if C245 is considered for the insert tools. What is C245? I'm going to be building a the Stealth Press Zero, whatever the new one is. I'm going to be using on-hand pieces. I need to get that printed. Probably try a different keyback style or keychain thing than what's called for, because the one that's called for is not readily available in the US. So anyway, there's one done. What do we got? Howdy, Steve and Chad. Just wanted to drop in, say hi, and leave a like. Thank you. Build's coming along nicely. Have a good day. See you, Redacted. JBC soldering station cartridge, amazing stuff. Now it's cloned and cheap. What is soldering station cartridge? What does that mean? Send you a link in Discord. Okay, thank you. Whoa, whoa, whoa. Wow, that is not an M3. What is that? That's not an M4 either. Oh, come on. Come on. You can do it. Come down here. Work that versus those are not right. So you got to pay attention to that when you're building. There's always going to be something weird. I mean, we found our special fastener, but just an example of, remember, our no thread in 3x40. Pay attention when you're doing stuff. I saw that looked weird. I'm glad I didn't continue because that would cause a problem in the build. It's not an M4. I don't know what that is, but let's put it in the little reject pile. Actually, let's put it in the, I'm not gonna risk grabbing that. Let's put it in the real reject pile. 3.7. It might not be metric, I don't know. Hey Josh, welcome. Hey Obi-Wan. Hey Ajax. Hey U3DP. What's U3DP stand for? Is that something you can share? This is easier to have that ruler here ready. It could be 3.5. And all the strange hardware mistakes, people actually buy that stuff for stupid money. I don't know why, but they do. Really? I'm paranoid now. Done with one, haven't heard on the shed in a long time. Any new developments? I went out and rearranged it a bit. As part of this big workbench here, if you notice the small workbench that was there is no longer there. That's an old Craftsman bench that I've had for like 20 years was what was there. That got moved to the shed. That was its planned eventual location anyway. So. We started to hear voices. Probably the Galactic Imperial Standard, where parsec is a measurement of time, not distance. First letter of my nickname. Oh, okay. You didn't like that screenshot I posted for Polar Ted, even Steven tries tacos. Oh, I did see that. Oh. So, lots of plastic shavings. I have an M5 insert where the threaded hole is at a 20 degree angle. It happens. There's no way around it. I mean, that was quite a difference, but it is something you gotta pay attention to. That could have been a pain before. 1 pound of drywall screws, no threads rolled on them, clearly noted in the list. $58? Wow. Who wants a coffee? It's about that time and the machine is on. Got my coffee here. Is Cactato still doing coffee? I haven't heard from them in a long time. Can you please give a link for that heat set insert press? It is the Vector 3D VLMP. I like it. I think having a heat set press in general is really handy. I wasn't sure I would like it when I first built this. But I use it all the time, to the point like I said, this is the Vector 3D VLMP. I'm gonna build the Iconic Lab one. Is that right? I may have to, there's a little bit of ooze out in the plastic on these. I may need to take a little file. Insert tool is killer, I love mine. Made with spare Voron parts. That's how I'm gonna build the other one, the Iconic one, is I'm gonna use spare parts. There's no reason for me to get a kit. Use mine a lot. I built both styles of the Stealth Press now. Yeah, I'm gonna build the Zero since it just came out. How's your Milo doing, Josh? Keep an X-Acto 14 with chisel blade around to scrape off ooze rings. That's a good idea. I'm finding if I go just a little under proud with these, I can put, basically when I push it back into place, if I do it right, when I push when I press it with the ruler here, it squeezes that plastic over the top of the insert. Hey, Steve. Nice and flush, and might give me a little more purchase on these inserts. I don't know. Milo dormant, hoping to make progress on Casa later today. Too many projects. I am going to model a dust boot for my Milo that matches the boot that's on my Shapeoko, because that thing is magic how well it works. I've done all that MDF cutting I've done. It doesn't leave any sawdust behind. The dust boot grabs it all. It's amazing. And I think I can make a very easy adapter for the Milo to use the same brush side as the Shapeoko. It's just a flat piece with magnets in it, and then a ring to clamp around the spindle. Now the spindle diameters aren't the same, so I can't use the same piece as the carbide one. But I think I can model a clamp, just a little screw clamp. Now the problem with this is, the next problem is the plastic ooze in the middle. Hopefully that doesn't get in the way. When you have too small of a modeled hole for these inserts, the plastic's got to go somewhere. So it comes out the top and it squeezes out the end. Built the Physetic press because it was cheap. It's decent, has an adjustable y-axis position, which is kind of neat, but it's not as good looking as the Stealth or VLMP. How do you like Milo so far? Is it great, or should we wait for the Cascade, if I'm remembering the name right? I think they're going to have slightly different purposes for me. The thing that's really nice about the Milo in its, go this way. Here we go. There. So the nice thing about the Milo is I'm going to use it open because I can put an extrusion on there that sticks way out to the wall as long as it's supported, and do holes in the end of it. I can't do that in an enclosed machine like the Cascade. So regardless, the the Milo is going to have a purpose for me. Okay, those are done. Sorry about that. They are not done. I missed two. Got two more. Hey, Joey. Welcome. I am having a good day. I am just a little annoyed with myself that I forgot to do heat sets pre-stream. So I'm using up half an hour of build time putting in heat sets. We are working on the docks. This is where all of the tools will rest. Milo looks tiny over there. Yeah. That table is going to house, basically going to house all the CNC stuff. It's fun to see heat sets being pressed. And if I grab my, let's see how this is going to work. Yep, that'll work just fine. There we go. Here runs one. What's the tool cost of this machine roughly? It depends on how many tools you do. Somewhere between, what was it, $2,500 and $4,000. Okay, do the docks require machine metal parts or is it entirely printed? There are some machine parts. Fans device worked out. I adjusted the end stop position and min position to be within 1 millimeter. Awesome. Gives you so Ron's, you're gonna have to go out to, the link is in the description to KB3D's website. You'll have to look at the configurator there. I'm not familiar with the individual pricing. My notifications are on. They are, thank you. Let me fix that. Streamer mode, engaged. Streaming the build, started watching it last night. What size is the print area? 300 by 300 by 2 something, I think. Yeah, Iconic Fab. Fab, not lab. I said lab earlier. Okay. Let's see where we're at now. So we did all the heat sets, did those, and then we need to install this 5 by 10 millimeter magnet. So it's gonna stick out a bit. So let me find this magnet. I'm guessing, is it in the FDM tools or is it in box here? Let's then make it larger. Can it be scaled? Yes, it can. Zombie is going to scale his. These are the 5 by 10s. Here we are. Okay, how close are these to 5 millimeters? No, this isn't a perfect measurement, but let's see. 4.73. If I want to try to press into that or not. These are big old magnets. I'm going to try pressing one. Let's see how that turns out. And we're going to use this guy, and we're going to go, I guess it just says it needs to be consistent. So the polarity on this just needs to be consistent. So I'm going to put one in, and then we will pay attention to the rest. So nice thing about Knipex pliers, they're magnetic. You just put your magnet there. Hey, look at that. I got it right. And then right there, and oh yeah, this will work. And I won't need any glue. Don't know how far that's supposed to go in. What is the depth of this thing? So it looks like it goes in 5 millimeters. So we want to see about 5 millimeters out. It looks like it can go in just a little bit more. Yeah, it stops well. Okay, there we go. Nice. So if I stick that on there and just grab them from the top and make sure I stick that there, it's going to be consistent. Hey, Jose, happy Sunday. Okay, so I'm going to do this part way so I don't have to keep adjusting my pliers each time. And then I will do the final press on all of them. So if I did this right, all of these should oppose each other. I try to touch them to each other. Yep. 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 Okay. So then we'll go up one. Press that rest of the way. It just needed like another 0.5 millimeter. Okay, that was easy. Nice. If those weren't so tight, you would want to use epoxy or CA glue to hold them in, but those are not coming out. I don't think I can get them out without destroying the part at this point. Now, I can barely fill an attraction that way, but that is definitely not that way. Magic elixir, nice. Solid and see the magnet should have a snug fit since there's no retention mechanism other than a friction fit for these magnets can be used to further secure them. Okay, that's there. Install 2 4x30 millimeter shafts. Those are in the motion. Are they in the motion box? Yeah. 4x30. There's 4x30s. I had coffee on my mustache. Hey, Kobe. Okay, install 2 4x30 shafts. Note that the final position of these shafts may be adjusted later. Normally, though, they'll begin flush with the back side of the dock. Perfect. Oh yeah, that's what I want to get, is a little arbor press. A little arbor press would be nice. But these guys are going to go in here. Now those are going to need to be adjusted. So I think that 4 millimeter reamer is going to be perfect for this. So let's do that. Right now, if I press those in and I need to adjust them later, it's not going to happen. So we're going to ream these to 4 millimeters. see how that, yeah. So that is a good fit. Tiny, tiny bit of wiggle, but not, these are for the dock, yeah. I'm going to make sure that that's clean between each one so I can hopefully minimize that wiggle. That one's done. How big of an arbor press? Oh, I have no idea what I should get. What should I get, Bill? For, you know what I do. What size should I get? I think that's a tool that would that I am missing in my arsenal. Must be perpendicular. Too late? So I'm not, I mean, I don't think I'm creating, there's an existing hole here, it's close. I'm not pressing, I'm letting the reamer find its own path. So I don't think I'm interfering with the beyond what the printed part is allowing me. See, my pressure is actually, my finger is at the back of that hole. A reamer is not a sharp point, so I'm letting it find its own center. Does that make sense? See the finger there, and I can also feel when it goes through. The more accurate, the more reliable it is at docking. Wow. It's going to have a set screw holding it off to the side as well. So. Seems to me if you'll do pressed in bearings, might be a good size. That would be small enough for the space. I'll have to look to see what a 1-ton arbor press looks like. I don't have a concept. Infinite Wisdom managed to print the wrong extruder mount with a, ooh, that's an expensive mistake there. Does it take that much force to press a bearing into printed parts? Oh, I'm not just doing printed parts anymore. I want to do all the things. It's Steve builds, not Steve prints. I just focus on printing stuff for now. Okay, so those are all done. So now these will go in here. And yeah, those are nice. There's actually no wiggle. My micrometer is not enough to be able to say if those are perpendicular. But they are a nice, like, I had to actually press, look, press that through. It doesn't drop in. That one dropped in. But I think that might have been the first one I did. Yeah, these are pressing in. Can't the wrench pliers be a good sub for anything on the desk size? Yes. So that is there, and then it's probably going to use, there's only a square. It's important that these shafts be perpendicular to the face of the printed part when finished with this step. If your print tolerance requires opening the whole diameter to accept the shafts, be sure to use only a squarely driven 4mm reamer included in the kit. 4mm reamer included in the kit. Did I get a 4mm reamer included in the kit? I don't think I got the 4mm reamer included in the kit. That might be coming in the second box. Any prints used for validating, checking print tolerances on a printer? Not really. Not really. Hey Max, welcome. Install and seat M3x6 set screws. Let's see if we can find the M3x4 and 2x8 and 4x6 and 3x6. Here we are. Oop, get you before you go away. Oop. So what I usually do for an initial round of tuning a filament or printer, of course this is after doing just rotation distance calibration or steps per millimeter calibration on the extruder, is I do print a 2mm wall hollow cube basically, but it's like 60 or 80 millimeters on a wall and 10 millimeters tall. I set that for two perimeters, and in Prusa Slicer, if you look in the perimeters section, it'll tell you what it should measure. So if you're at 0.4 millimeter wall width, it's not 0.8 millimeters that you're looking for. It's actually 0.6 millimeters. So I start there, and then I tune by a print, and I look at the top surface on prints and go from there and look for other fitment things. Does that make sense? Did I explain that well? Did I miss a question there from you, Kobe? This is a tool changer, yep. Spool switch in the AMS, screwed up a full sole parts print, oops. On the back left, that's the Blackbox CE Steve is currently building. Right there, yep. It'll come back on the desk here in a bit. We are fixing all of these in. You sore, Max? You looked tired in the picture. Get a grasp on things like super slicers width and flow and how they all add up. I had a whole hell of a time when I was starting early, when I was first building my Voron, and having all kinds of trouble with bearing tolerances and stuff. And I didn't realize that I shouldn't be going for two perimeters should be 0.8 millimeters. It should be 0.76. And once I realized that and use that as my basis for tuning, things got a lot better. Oops, I need to stand over here. I need to fix all that, where my cameras are and stuff. I've got plans on where the cameras are going in the other wall there. I'm going to have a lot more adjustment in where they go as well. I'll do this one off the side so it stays flush, because this was the one that was just slightly loose. There we go. Two more. Any of them get loose? No, okay. Hey Ben. Also cauliflower. You know, I haven't tried Adam's calibration print thing. I don't know if that'll end up being one of those things like I hadn't tried a filament press or a heat set press. I hadn't tried the belt tuning device from RS makes. Maybe a calibration print is what the next thing that I try. Yeah, I'm screwing this in from the side of the desk just to make sure everything stays flush with the back. Consistent. Okay. That is those. Set screws will travel well into the printed parts. Install a printed tool dock wire guide and secure with an M3x8 flathead. M3x8 flathead. Is that what these guys are? M3. That's weird. Don't forget to smash that like button. Gotta go. See ya, Timo. Cauliflower isn't bad at all with that. You don't need to get your frame 1000% square, but can correct it in software. I wouldn't rely on that. I would still make sure your build is accurate. Little wire guides. Takes credit for belt tuning. Yeah. Is that what I said PF, right? I said PF? Or did I say RS makes? What did I say? This guy goes right here. The build should be as accurate as it can be in the first place, but it's tweak the last bits. Go. Now that, yeah. Sunday fun day. Major Gamer Geek. What happened to your other? Do you have 2 accounts? Or did you change back? Additive atom? No Loctite, guess it's plastic in the middle. Yeah, this is all plastic, plastic, plastic. Yeah, I never use Loctite for something like this. The plastic has a little bit of a elastic effect on the tightening as well, so I don't want to risk getting Loctite on the ABS. Have a late dinner. Hope I don't miss the giveaway. You got an hour and 46 minutes. Hour and 46 minutes and 178 likes to go. Was on the old account on the tablet. Didn't mean to call you out there. But I'm sure you hit like on both, right? Okay, there we go. Little thing. Install a tool dock PCB and use 2 M3x6 socket heads to secure. So tool dock PCB, is it in here? Kind of neat to start getting into stuff. There they are. Tool dock PCB. And 3x6 socket heads. Tool dock PCB. I don't know what that's doing there. So resquaring my trending gantry is one thing I don't look forward to. Must have bumped something when I turned it over the last time. Now my bed looks like a taco in the mesh. Ooh. Let's see what we got going on here. I see. Okay, M3x8 socket heads. These look like 6, so these must be the 8s. So this goes here. These go, oh, well that's, is there a printed part in there? Is that what this was, or there's no printed part there? I don't like that. All the pins on the back, so this is just kind of sits there, pressing into the back. That feels like that could be tweaked a bit. There's no positive stop for this. So trimming the pins is a problem because I can't really trim. I don't want to trim the plastic pieces of the connector that push through the board. We're going to go with this right now. But I think it would have been worth a little printed part. Now there's little printed parts in here, but I don't think that's what these are. Yeah, the spacing on that's wrong. Yeah. But that's, if you tighten those too much, then it's just going to warp the whole thing. I think a little spacer would be useful. We're going to go with this, as the instructions say. That might be something I tweak, add to the project. So let's put all those on. I don't want to take the time, but see these plastic, there, the black plastic from the connectors I'd have to trim as well, and I don't really want to trim those out. Sending to Chris, yeah. Might use some M3 washers because that's going to be fiddly and a pain in the neck. I'd rather deal with modeling a quick little spacer and printing it out later. Yeah, trimming the pins because I don't know what other connector spacing and stuff that relies on. We'll leave it like that for now, and look at tweaking it later. Channel my inner spacers, yes. I am hoping to have an opportunity to meet him at OpenSauce in a few weeks. Yeah, that just needs a little 2mm printed spacer in there, and it could be put in and not extend past the bounds of this PCB too. We have a bin full of different thickness printed washers. Wouldn't have enough of the correct thickness for this job though. Do you have M3 nylon washers? I do, but I'm not going to sit here and stack up nylon washers and deal with the fiddliness of making that happen. So it's not a big deal. We are going to go with this as it is, and I'll deal with it later. I'm not going to try to stack up 4 or 6 M3 washers here on camera. I've spent enough time dealing with tapping and putting heat sets in that I was supposed to do off camera. Okay, so those are done. It's not that big of a deal, but I think it would have been better with a spacer. Okay, tool wiper assemblies for FDM tools. So 2 inside inserts are to be installed from the back side of the printed part. 2 inside. So we're looking at this and it says locate one of the printed parts and install 4 M3 heat set inserts in the shown locations. Note that the 2 inside inserts are to be installed from the back side of the printed part. Let's see what that means. Okay, that's good because that'll be easier to get to. So this is the part I'm saying we got 2 inserts there and then we turn it over and put 2 inserts there. I've decided that most of the world doesn't understand mechanical stuff. I watched 2 sessions of Red Bull Soapbox Derby last night. I'm sure that was entertaining. Okay, we have 5 of these to prepare. So let's get these 5 prepared. It's a later build, Steve builds problem. Exactly. So we're just going to do... Oops, not throwing that away. I think I need to invest in a 4.5 millimeter reamer or 4.7. Actually, 4.7 would probably be ideal. Just so I can clean up stuff like this. These need to be fixed. These need to be fixed in the model, but like I said, they are for the next step, for the next guide. I just didn't do it on these. Hey, Martin. I've got the Uzi bucket thing on my list too for that exact purpose. Yeah, it's a really handy little workbench, quick debris receptacle. Oop, that wasn't debris. Yeah, and this is the in Cookie Clad Witchcraft. I think that's what that was. Okay. Heat sets. Holes where? What? 4.7 for heat set inserts. That's what we... No, so you're right. We model them at 4.7 because of 3D printing characteristics. But yeah, 4.5 would probably be a better size to buy a reamer for these. You're right. Not a 4.7. That would probably end up being too big. What's your recommended storage system when it comes to M3 screws? I'm thinking about Gridfinity. I'm partial to this. I do not think that I can get this kind of density in Gridfinity. Gridfinity would be more flexible, but this is very dense. These are inserts that I designed for the Acro Mills, and I have some for the Harbor Freight bins as well, but I can fit a huge variety of hardware in a very small spot. I was annoyed by slightly too small holes for the inserts. Yeah, these are as these are modeled, they're a little too small. Well, because my ADHD won't let me finish a Gridfinity project. I am going to do some Gridfinity stuff. I'm going to organize my tool chest here with Gridfinity and probably a few other things. Let's get this in here and ready. Still have a few Screwfinity sizes complete, but it's good size for M3 storage. Yeah. So I may have to reprint that. As I was pressing that in, the plastics part was splitting. So I am going to continue this, but I'm going to mark this one as maybe being a problem. And I was putting probably, let's go a little higher on my temperature here. Oh, no, no, no. That's not what I want. I don't know how to use my iron. There we go. I'm going a little hotter on this. I'm going up to 240. I usually do it 230. There we go. And I'm going to go a little slower on these so I don't risk cracking any more. I think I just put too much pressure on that one in a thin spot. I hit the wrong button and go into the menu on mine constantly. Yeah, that's what I did. Yeah, there's a little bit of a crack in that one. I'll install that one last. So I'm going to go a little slower on this. Did not crack that one. Just thin spots. I used to use inserts for 5mm smaller. I use Alexandria Chappelle system for larger screws, bolts. Yeah, also with my setup here, I realized that it works pretty well to just kind of set a volume for those, for each size, and just accept that I may only be able to fit a few of a size in the bin, and then I have a generic container with extras. So then I'll just make sure that I check for the extras before I buy. Like I have a ton of M3 by 10 stainless steel button heads. I have a whole one of these undivided bins worth, but I don't need that. I don't need access to that many at a time. So what this is for quick access to fasteners for builds. It doesn't have to store all of my fasteners. It needs to store the most used things, not just fasteners, because I've got other things in these as well. I could have saved so much time today. I'm so irritated with myself. Oh well. One for, and the other for electronics. Use a small Amazon box and an upper shelf to store boxes of refill screws. Yeah, exactly. I'm gonna end up using one of these style bins. I just get these at Target or whatever, little Sterilite bins. These, I've got a ton of these. They stack well. Through all this, because I've been doing a ton of sorting and organizing and cleaning up, and what the biggest part of my mess has been miscellaneous boxes, right? You've got a box of things that you just kind of emptied the current project when it's finished off into. So I have boxes of extra fasteners and printed parts and all that. So all of my time has been going through all of that and cleaning them up. And one of the things that's resulted from that is I was basically down to about 3 heat set inserts before that. I've gone through and recovered and also found the little spare bits. So now I've got heat sets for days now, and I didn't have to buy any more. I was out basically at M5 by 10 black oxide button heads, and I've got that bin is well stocked now, and I haven't even finished going through stuff. Jacob, thanks for the super chat. What slicer do you use for Blackbox to work? Well, when I'm finished with the build, I'm planning on using Prusa Slicer because it is really set up well for multi-tool head printing. Some of the others have quirks still, but it will be Prusa Slicer. Dr. Dave, working on my shed today, so in and out of stream. Have fun. Thanks for stopping by. Not cracked any more of those, so a little hotter and going slow seems to have done the trick. Eclipse, happy Sunday Steve for build supplies. Thank you. Thank you very much. It is appreciated. I went to Home Depot yesterday for supplies for that filament rack and realized that it's like 6 or so 10-foot sticks of conduit, and they're $10 each. Is that the KV2D parts kit for the black box? Yes. Okay, so those are done. More heat and less pressure is a good idea. Yep. Okay, so locate the below printed part and install a silicone leak blocker into the channel as shown. This part is located in the FDM tool hardware kit. Interesting. Yes, there is in there. Here we go. Just a single bag of groceries now. It's like, I feel your pain. Home Depot. Thank you. So there are a few silicone pads here, but one of them looks like the picture. What do you think about new Voron IDEX printer? If not wrong, called as Phoenix. There's Phoenix. Right there. And the dart in the garage door still. Okay, this guy and a printed part here. Hey, BBs. Goes in there. And what do we do with it? Install onto the main nozzle wiper printed part and fasten using M3x10 flatheads. Okay. So we're going to put that in there and install that in there, and then we can adjust that up and down to make sure that we're properly wiping the nozzle. Could be very interesting if the tool changer works well together with the RCF. that would be insane. M3x10s, that's these guys. So we will need 10 of these. 3, 4, 5, 6, 7, 8, 9, 10. Who is a good idea to properly wipe? Everybody is. So I don't think this needs to be tightened. Let's see, it just needs to be tightened enough to compress and hold the wiper in place, and there's not a lot of force on there. And then right now that's flush with there. I don't know what we want to install that to. This will end up being adjusted. Let's make sure that's all the way in, and then let's push that up a bit. Oh, sorry about that. Right about the middle of travel. That's what we'll call it good. Like that. Hey, Brian. Hey, Sir Guy. I was wondering if Voron Design will do a Phoenix Mini with a single bed. I think we should do a Phoenix Mini with four V0 beds. That would be awesome. That would be fun. I'm going to go through all the toolkits and grab the silicone pad out of them. All learning from Phoenix and produce a more convenient size version. FDM hardware kit. And I resorted or replaced all the Blackbox hardware. It was getting a little unwieldy in its original box it was shipped in. So, there we go. FDM hardware kit. So we got 5 of these. I believe Chris cuts those with his laser. Oh, neat. Okay, now I'll actually look at what I'm going for instead of reading chat. 3-phase powered Phoenix. It's kind of going the opposite direction of convenient. Phoenix Mini with 4 micron beds. Then you can use an XL bed sheet. Voron 2.4 with 4 Trident Zs for the gantry and 4 V0 beds. Oh, the backpack electronic setup. It makes it makes for a very deep printer. I mean, most people only have 22 or 24 inches of desk space. What's a 350 look like with backpack? Okay, so that's those. 1, 2, 3, 4. We're going to go ahead and use this. How can I distinguish that one? I guess I distinguish it by the one that fails as the one that was probably broken. Hey, Duff. Off topic, does anyone know of a good tutorial for the new BQ eddy current sensor? I have one. I haven't tried installing it on anything. Hey, Geocacher. Oh, we got... Does that notify me? I saw something come up. Hey, Ember. How are you? Hey, Grant. Hey, folks. How was the interview with the EDM folks? Everybody that's showing up, make sure you hit that like button. See if we can get our 300 by the 3-hour mark. Hey, Grant. Who else do we have here? Geocacher, my name is Underhill, MR. Very interesting, lots of nerd talk. It's up a bit. Just above. Light gray text on a white background. That Grant rated. What? 2. This one. Ooh. Got some there. I gotta clean up. Which version do you have of Eddy? I don't know. That's a good question. I have I don't know. Those filament white blocks, they are. These are for these are the docks for the tool heads, and this is supposed to help wipe oozed filament off. That's an inherent problem for all of them. What date was it? I guess not Mandela beds with Eddy. Oh yeah. With any inductive style probe, you're going to have trouble with magnetic or beds with distinct magnets. Oh, does it actually rest here, Hoity? If it rests here, then yep, for sure. That's how I have my Tridex set up, is to rest on there. Cannot do tap with those changer heads, or yes? Are you talking about on this? Put his hair on screwed. This is a tool changer for CNC. No, for printing. It is a 3D printing tool changer. No. On the tool heads, can they do tap? There is not a design right now for this to do tap. There it is. Last one. An Eddy program called the Munster. Okay. So that is those 5. Locate the blow printer part and install 2 heat set insert into these locations. Oh, and there's, okay, so that's the rest. These are the wipers. Got it. So the nozzle's gonna rest there, and these are gonna wipe the filament. And there's a bunch of little spacers here, and that's what all these are for. Grab all these out of here while I'm at it. Okay, I think that's all of it. Okay. Do a quick cleanup on these. Just for a particular printer. This is a Blackbox CE, which is the latest revision of the Blackbox project. It is CE for Community Edition. The Blackbox project started in 2016, 2017, but Chris at KB3D has kind of championed updating it and making parts more readily available for folks to build one. It is fully open source. GitHub link is in the description. It is its own thing. It's not based on Voron. It predates, doesn't predate all of Voron, of course, but it is its own thing. Heat. Heat sets there. It is an entire printer. Yep. You see it's tiny view here. Right here is the frame. This is what we've worked on in parts 1 through 3. Now we're just getting all these dock parts built up. I watched their video, but never heard of this. Yeah, it was pretty under the radar. So that's the whole idea here, is to bring it out front, right? Oh, hold on. That one. Heat sets, our favorite thing ever. It should go relatively quick. Let's kind of stage them right there. Last time I was in chat was during the Micron build, was remixing Legacy for a rod-based Triple Z, nearly a whole year break later, and I have the working kinematic. Awesome. This tool changer setup immediately strikes me as 100% game changing. I hope that it is game changing for me. I ran into issues with my Tridex that I'm hoping I'm on the tail end of sorting out. So some level of non-ERCF or MMU style filament and material changing I've been wanting to do for a long time. Nozzle blockers, it is never suggested to dock or undock with the tool cold. Oh, does it kind of stick? And you get to replace them. Look at this. I'll talk more about this. There are some good ideas out there that haven't been getting too much press. The you said Juniper, but I think it auto-corrected, but Jubilee is another tool changer project that's been around a long time. It's always been interesting, just never ended up on my build list. I think doing support material and PET G on ABS parts is my favorite thing about tool changing. Can you do PET G on ABS parts? I think dissimilar or incompatible is probably the better term. Incompatible material supports is really interesting, but I think there's also a whole new set of considerations when doing that. Like, you can't just create an island of that incompatible parts because it has nothing to stick to. So it's probably still has its limitations. Hi, Kit. What probe are you going to use for the bed mesh? Are you going to use the dual IR like the build suggests? I'm going to use whatever the build suggests. Out of the hobby last year, we are the favorite Voron mods additions that have come out since your Micron build. That's a good question that I don't have the mental bandwidth to go through right now, TechHead. Smash the like button, 280 people. Yeah. Think that you can do nylon with ABS ASA for support interface. Lots of cool ideas. Oh, I've got these parts coming. Huh? Okay, let's see. We've got that there. Then we've got those heat sets in. Locate the nozzle wipers and the print nozzle wiper part 3. Each wiper will be separated by 2 printed parts as shown. Secure the stack loosely using 2 M3x10 socket heads. Note that the height of the nozzle wipers will be set later. Be careful not to over tighten them. Fabrico, thank you for the gifted memberships. In and out today with family stuff, but the youngest fan says, hi, hello. It's a high temp Z switch. Let's see, apparently I never heard of system D. Welcome all the new members. Thank you, Shammy. M3 by what? M3 by 10 button or socket heads. M3 by 10. Really? Are these in the FDM tool, FDM parts hardware? Probably. There's M3 flatheads. Let's see what's in here. There's little hardware kits for the FDM tool fastener sets. I don't have enough in the main build, but I'm guessing that they are in here instead. 3x16, M3x10 button heads. M3x10 flathead. So M3x16 flathead, set screws, flatheads, flathead. Those are M3x16, M3x10 button heads. Yeah, this says M3x10 socket heads. I'm hesitant to use anything else at the moment. In my toolbox here, unless there's a supplemental bag of them, which I have seen some of that. Let me make sure I'm not missing something. I only have 6 M3x10s left in here. I only have 6 M3x10s left in here, and I need 10. I have my own, but that's something to note. Nope, those are 12s. Maybe I'm looking in the wrong thing. Yep, I may have been looking in the wrong thing here, Boydie. I may have been looking in the wrong thing. These don't look like 10s though. No, those are 8s. Yeah, I'm completely out of M3x10 socket heads. So I have none. M3x14. I have none. No. I'm wrong. I put them all here. Never mind. You don't have to tell Chris. It's all my fault. Yep, there's my 10s. Nope, all my fault. I forgot I put those sizes early on in the bin. Now I've almost thought I was missing them just internally a couple of times during previous streams. And I realized before vocalizing it before. So far, I don't think, have we been missing anything so far? I don't think I've had to go to my supply for anything on this kit yet. See, Arthur? Being organized isn't always good. I'm organized in 2 spots is the problem. And that has been the problem, right? In 2 garages. So now I'm trying to be in 1 garage, but I'm in multiple spots in that garage. Pulling all these out. I let him know that you lied. Yep, I lied. Missing the most important thing of all, our minds. Yes. I feel like I'm missing my mind. I should not get hungry today. I showed Garrett the picture. I had 2 big egg and ham and cheese tacos, basically, with Pueblo Red on them, and it was delicious. I had that right before stream, so I am doing good on the food. Okay, we're gonna build up this stack, and I don't think that should be too much of a problem. Go here, and then we got a bunch of these. I don't know if I want to just kind of build this on fingers here. Yeah, that might be a little. I think it'll be easy enough to build it on the piece here, since it's all flexible. Just set that in there. Yeah, this will be easy. The kids just use all the wipes. I'm so chilly. Smoke signal, please send more. I am a hot sauce weakling, but Pueblo Red is right exactly at my speed. I'm not even going to use a wrench to tighten those yet. I'm just going to put these together. Let's see how. Let's stack these up. There is a slight offset in the hole. I just finished Fallout. Just watched that. Finished that series while I was working out here yesterday. Anybody else watch that and enjoy it? The only game that I have played through in that series is actually that should go this way, I think. The only game I've played through in that series is 76. Oh, which way this should go? I think it probably should go the other way. Trying to figure out which way the offset on these should go. And I think the offset should go that way, there, but that way, there. Yeah. Oops, sorry. Love the games except 76. 76 is the only one I could get myself to finish. Okay, so that way. No, I'm wrong. New Vegas is the one that I finished. New Vegas is the one that I finished, not 76. New Vegas is the one that I finished. I could never get into 3, and then I didn't really try to get into 4. Okay, so I was paying attention because if you notice here, it's not quite centered, and I don't know if that's intentional or whatever, but it's consistent. So I'm trying to pay attention to which direction those go. And did I get it on this one? I think I did, except for those need to be flipped around. There we go. Fallout 4 is my favorite. Okay, so those over there. Let's keep going. This, that. Right like that. Okay, and that one, and there, and that right there. Love the names of the Fallout. I have to find the water. 2, I have to find the Gek. I don't know what that is. So much doesn't even look like the original game. Hey, Scott. Hey, Alan. Every time watching you build in the black box, I had my first attempts with TPU. In the end, it worked. Awesome. TPU can be interesting. I have some of that coax 60A. I still need to figure out a setting to print and a printer to print it on. Hey, Collie. How are you? Did you know the microcontroller inside the TS100 is push fit? If you ever have the power flickering or screen glitching, the microprocessor has come loose and not the barrel connector. Interesting. This is a Pinesel, but I do have a TS100 as well. Okay, one more. Uh-oh. I'm missing one of the little flat pieces, the little spacers. I'm actually missing one. Is it up inside there somewhere? No? Huh. I am missing one of those. And I'm missing that goes there, that goes there, and that goes there. Seen Adam releasing the VLMP2 soon? Yeah, he had those at Rocky Mountain. Okay, I'm gonna just put a screw in here. It's a small piece. It's probably sitting in the bottom of the printer. I will look for that later. I'll just put a screw in there for now without the spacer. It's not a 5-second print because I'm going to want to do it in the same stuff. And that means pre-soak and all that stuff. Where did that come from? Let's come from one of those. Secure the nozzle wiper subassembly to the main nozzle using M3x10 socket heads. Imagine that. That goes in. There's a little. So annoying. It's like 6 or 7 minutes prep time and 30 seconds of print time. Exactly. I will just print it later. It's not. I can swap that out without any problems. These are meant to be easily adjustable. It would be nice to be able to get to that screw through that part. And that one's going to be a little more difficult, but why is that offset? We'll have to see why it's offset later. But if that needs to be adjustable, I guess you can just take this off and adjust it. I did not forget a spacer. I can't find the spacer. So. But judging from how this goes together, I'm not too worried about which one of these I cracked. So let's put all of these together. What do we got? 4 new barrel cables before I figured out the one. I think the pine still uses the same basic design. Few mods, but don't quote me on that. Okay. So 966, oh yeah. I'm printing a 2-inch tall Stay Puft Marshmallow Man for my 3-year-old nephew. 2 foot tall, not 2-inch tall, 2 foot tall. The nozzle committed. Oh no. What, lost spacer? I'm going to be so disappointed. Well, this is the spacer stream, right? I need to print some spacers for this, and I need to print an extra spacer for that. I'm curious why that's offset. It's longer. 10. I got some longer screws mixed in there. And these could be 8s. There's no reason that these are 10s. But that's not really feedback. Just a note. If the entire build, everything could be 8s instead of 10s, then that would be feedback because we could reduce the BOM by a fastener. Why would you need to adjust the resting block for that? This height is adjustable. There's a slot there, so you can move this up to where the nozzle is resting on there. So yeah, you need to adjust it. Now it's not too arduous to just take this plate off, adjust that, then put this on. You have to take it off anyway to adjust these. So I guess it doesn't really matter. What do we got? 284 people here. We have 49 minutes to get 118 likes. Can we do it? See, there's a little spot there for the nozzle to get past. Okay, those are done. Can we do it? Repeat this process for as many FDM tool headers you will be installing. I'm going the full 5 on here for anybody that doesn't know. We're going straight at it for the 5. Okay, tool dock, spacer housing, and install an M3 heat set at the location shown. And there's a part that snaps in there and a part that goes there. Okay. Ooh, we're almost to a machine part. 1, 2, 3, 4, 5. I'll need all of these. That is fair claim. Maybe Steve should just start building bigger stuff. What was Ivan's spacers tend to be much larger and more difficult to lose. That's true. Okay, we have a heat set to put in. Oh, which side? It is this side, and it is that one. It's the heat set. Well, that's interesting. If we look at this, that's very definitely a chamfer or fillet there. It was not on here. Maybe it's just so small it doesn't show up in the print. Ah. So it's only the TS100 that uses a push fit. What would you rate this on the difficulty scale as a project? Ask me again when we're done. So far, it is definitely on the more complicated, you have to pay attention to things scale. But there's nothing really significantly difficult. Yeah, I'd say probably similar to a 2.4. Somebody at Blackbox might want to fix the bomb PDF 670 blank pages. Really? That is not where I wanted to go. I wanted to go here. Let's turn this thing back on. And there. How does this go? Is this compared to a mega upgrading an Ender 3 V2? I don't know what a mega upgrading is. There's an updated one coming. I have a tap and die set on my card. I'm getting an itchy wallet seeing you use yours. Well, this is just the difference. So you said tap and die. That's for creating threads, internal or external threads. These are reamers. Reamers are a really handy tool. If you're in the US, KB3D carries a set of reamers for a really good price. And I think, at least they used to come with a neat little laser cut holder for them. So reamers are super handy, as well as the good tap and dies. Hot sauce can trigger heart attacks. Mega upgrade equals Enderwire. I feel like it's its own thing, but anyway, I'm just looking at these parts and how this is going to go together, making sure I have everything right. I guess this can just go like this. This can go right there. That. This doesn't look like the right thing. Well, what's puzzling me is these are slots. These do not appear to be slots. It's hard to tell. It also looks like that's not square, but I think that if you look here, there's a line there. I think that's the edge of the screenshot. That might be something a little nitpicky note. If you look here, this makes it look like the part has an angle on it. Very nitpicky, but, and then I'm not sure how these go, because if these are supposed to be adjustable, oh, they are. Okay, they're a fit, so they're adjustable, so that's good. Okay, so we're good. So let's put all of these in. Let's wake that up again. Go here. Get these. So I don't have exact pricing because it depends on how Gucci you go with the build, how many tools you use, which tools you use, all that kind of stuff. A fully decked out black box will set you back close to $3,500 to $4,000 US dollars. And that's about as close as I'm going to be able to give you on an estimate. You'd want to look at the configurator at KB3D or look at the BOM and self-source it, because you can do that too. If you're looking for a high quality tap and die in the US for metal and plastic, check out Viking Drill. What's the source on that, Bill? Where do you get those? I ended up I wanted something on hand for not a lot of money. So I just bought a metric tap and die set, mostly so I could use the dies. But I just bought a set that looked reasonable off of Amazon. VikingDrill.com. Okay. You actually have the ability to put a full link in chat, by the way. Perfect. Use the taps a lot more than the dies. Me too, for sure. For sure. Okay, now we get to put, so if we have this guy, that's facing there, then this goes on here, and this does slide up and down in that. So this will give us an additional adjustment. What I wanted to have a set of dies on hand for is when I need to cut. Now you thread a nut on all that, and that can help, but really recutting those threads, I think when you're cutting a bolt shorter, just recutting the threads is easier and quicker. Just making sure these are all fitting in there with the proper movement, and they are. They don't snap in, so those are just setting in there. So those will just set like that. Locate print tool dock spacer. So these I'm hoping actually work, because these are a really small part, and this fiber filled filament I'm hoping didn't make too much impact on the dimensions of them. See how they go. So temporary loosely secure. You don't have a Knipex plier with thread cutter? I do not. Diameter tends to twist bulby and cut. It's really easy to rethread a cut bolt. Just use a nut or two on it beforehand and then take the nuts off afterwards. That doesn't clean them up enough, Josh. There's clearance there for a reason. on those nuts so they can thread on and off. I've had many instances where just unthreading the nut doesn't clean it up enough. And that's why I wanted just the ability to clean up deformed threads a little easier. Threading on the die before cutting guarantees the new thread is aligned. That's what I would do. If I was doing it, I would thread it on and then cut it and then take the screw out. Anyway, we need an M3 by 35 flathead. This piece will eventually be used to secure a spring wire that helps manage the wire loops to each equipped tool. Also, it's different if you cut a thread or roll a thread like screws are made. Yeah. M3 by 35 flathead. Is that this guy? Yep. 5 of these. So this is going to go, this is going to go through there. It does. Wow. That is so close to splitting though too. And then this is going to go that and right in there. Okay. And probably threads into the, yeah, threads into that heat set that's on the other side. Oh, that goes in quite a bit. I don't know how much I want that to go in, so I'm just going to thread it in. Just says temporarily, so I'm just going to thread it until it catches threads. Get a Knipex 9721. Can you link me that, Nappin? In the Discord. Okay, those are going on well. And that goes in there. Presses in there. Just get that just barely to the point. Oop, nope. Got to get it to the point where it touches the threads on the other side. There. Is it worth switching to Dragon Burner with tap adapter over Stealth Burner? I don't know. I've not used Dragon Burner yet. I plan on using one, setting one up in a build at some point soon. Potentially the solid fork rebuild, but I don't know. So I'm just making sure that that pushes into the printed part. There we go. And push this through. I'm curious why, and we'll see. One of the things I'll be curious about is why do we need this printed part at all? Why not just use a flathead that goes in there? We'll find out why. I'm just glad that these seem to have actually printed well enough to be useful. That was a big question I had, and whether those tiny parts would be useful. Okay. Dragon Burner, I'm kind of wary of going back to 4011. So it's for securing a wire. Oh, I see. It's for securing a wire. Oh! Oh? I don't know. We'll find out. I wonder if that, oops. I wonder if that goes into that little spot right there. It might clamp it in. Repeat this 4 additional times. Here we go. Locate the tool cooler. The cool tool cooler. Cool tool cooler. Ooh, this is a Mandela Roseworks machined part. See how that actually plays in. Place each tool dock assembly against the idle tool cooler. Ah, right like that. With the magnets poking through. Each tool dock assembly against the idle tool cooler. The 5x10 magnet is the only contact point until the next step. So this is going to go like this. The magnet should pass into the tool cooler with a slight press fit. If required, the tool cooler can be reamed to 5 millimeters. Now duplicate that on mine. Yeah. It could. I think it's within the build volume. How wide is this thing? What is X volume on the Milo? What's X volume on the Milo? This is not a complicated part. This is 380. I think it's outside the Milo. I think it's outside the volume, build volume capabilities of the Milo. It's 380 millimeters long. Okay, let's look at this. So I'm going to be a little nitpicky here, and I might not need to be, but this side is all nice and clean. This side has the little burrs from the tapping the holes. I'm going to go in real quick and just clean those up because I can feel them. I'm just being nitpicky here with this. You can do it, Milo, just now. Oh, not with one step. I'd have to move it. You're right. I could still do it. Plus, I get a chance to use my Noga tool. Okay. And nice 5mm holes would be great. Registration point. Yep. You're right. I could do it with multiple setups. That's the nice, kind of a cool thing about that. I mean, you have similar things to think about with 3D printing, but just the logistics. How do you do something like this? What is the setup? That's fun to me to determine what that setup looks like. And coming up with creative solutions. Okay, so these are going to go on here. I don't know what's to start, but that goes right in there. There's no reaming required. It is a good fit. And then screws go in. No screws yet. So this is the heat sink, basically. There's going to be a water block on this side, I think. But these all go across here. And then I'm guessing this goes here. Something like that. So I don't know how they want me to hold this. Should be either flush with the face of the tool cooler or slightly below flush. Any magnets that extend past the surface of the tool cooler will cause a loss of conductive heat transfer. So these are slightly under flush from what I'm feeling, at least that one. If one or more magnets are too far exposed, now is the time to press them further or diagnose the cause of the extra height. If I was doing this again and it was important for these to be flush for magnetic strength, I would probably have pressed these in the final press with this right here and just gone across this. If I was doing this again, I would probably, because it is under flush by probably 0.5 millimeter. But if magnetic strength was important, I'd probably do the final press of those after this was on here. One thing that might be nice is maybe a hole through the back here that would allow you to press press those magnets out if you needed to. We have 28 minutes and 94 likes to go. Okay. Fix all tool wiper assemblies and thus docks to the idle tool cooler using M3x16 socket head and loosely tighten. These fasteners will be fully tightened at a lighter step. So we're going to put this is what's going to tie everything together. So I'm going to just start on the end because it's going to be not realistic to hold this whole thing together while you put this assembled. So they're there in M3x16. M3x16. These guys. Nope, that's 20. And 3x16. There we are. I'm gonna be like for my other 94 accounts. Okay. So confirm that is under flush. Now this goes in here. Don't forget to put them, oh, I know. I thought about that as I was putting them in the tray. I need to, I'm off center here with the overhead camera because I keep wanting to do my work right here. I need to do my work right here. Okay, so now that one goes on. Okay. I'm not tightening any of these because I think we're going to line everything up later. This will get more and more stable the more of these I put in. Maybe I'll put this one in down here. Under flush. Have you seen the Voron stylized Gridfinity boxes on printables? I have not. I have not. Who did those? Did I grab the wrong size screw? That thread's in there. Why wasn't that threading in? Goes there. No idea. They need to print one of those parts trays. I like them more every time I see them. Link to my printables profile is in the description. That's where you can get them. This is the exciting part. We're starting to get into the actual tool changer stuff. Set of, those are the docks, tool docks. 5 docks in that distance. It's pretty good. Okay. Install one of the 2 water blocks and install 2 BSPT tube fittings as shown. Ooh. Ooh, water block. Is that in here? It is. This is even more exciting. Got a water block. Now, is there any things? I think that's yep, that's a protective film on there. Looks like you have all your docks in a row. See the fins in there. There we are. And then BSP fittings. These guys? It must be those. Are those a water fitting? I guess so. Okay. The original design is titled Gridfinity Storage Box by Voron Stylizes Printables Model. Okay. Is that what I want? Is that right? It doesn't look like the picture. Is there something I'm missing? Locate one of the 2, install 2 BSPT tube fittings as shown. Are there other fittings? Are you going to use a funky coolant color? I don't know. No, those are not what I wanted. These are PTFE tube fittings. I was confused. These are not what I want. The water cooling bag, water cooling bomb has, I'm guessing these. I'm hoping those. I think this is what we're talking about, right? Yeah. Those go in there. And they're already sealed. Yeah. So someone with Discord installed, post that to the general chat. Stream chat. Stream chat. Okay. So that's these 2. What size is this? 14. Grab a 14. Yeah, I get extra tape, Teflon tape. Okay, I guess we want to make sure we don't cross thread these. I'm going to start them by hand. The first one's going to be easy to put on. The second one is not. Is there anything wrong with changing the teeth idlers and the stock XY joints to smooth bearings? No, I do that. I've done that on printers. There may be impacts in some edge cases or some level of belt tensions and speeds and stuff, but for the most part, I haven't had any trouble with that. I don't know how much, that's pretty tight. I don't know, I don't think I want to just crank that down all the way. Should go. I guess that's about right. That's a few ugga-duggas there. I'm gonna go with this as long as I can get away with it. How do you always make the build? Oh, shoot. I need to pay attention. It doesn't look like it hurt it. Looks so seamless. Preparation and just kind of following the basic build techniques. Just gonna go about as much as the other one was. Go. And they're parallel to each other. Artifacts versus better bearings. What are the alignment? I don't know that you'll get artifacts. It's just it's certain combinations of tensions and things might impact it. I do not have a loop leak tester. Welcome back, Marcel. Okay, so that is on there. Insert two 64 millimeter lengths of tubing into each fitting. Achieving perfect lengths and square cuts is not necessary. The sealing surface for these fittings is an O-ring seal against the OD of the tubing so that no cut debris enters the tubing. Always practice good safety when working with the blades. Be sure the tube is fully seated in each fitting. Okay. So two of this stuff. Two 64 millimeter lengths. I have never done my own custom PC water loop. I'm gonna try one of these. I'm gonna cut what's here off because it's not super clean. Yeah, that's pretty good. Not 100%, but it's really good. Time to scale up your PTFE cutter. No, that was fine. I think this is about an appropriate size for it. Do I have the... No. And then 64 millimeters. And the length is not critical for it to be exact. So somewhere around there. So 64 millimeters is right at the middle of the M and 6 millimeter ID. Middle of the M, 64 millimeter ID. Now if I hold these parallel there, I think I'm likely to get a straighter cut. Yep. So get a nice cut there. And then more of these. It's going to be right to the middle of the E in free in Wade. Middle end of E. Yeah, nice square cuts. Paying a little bit of attention on that. All-in-ones, water coolers are easier, and if installed properly, should be good enough. And that's what I've used. I don't overclock my machines. No, nothing against it. I just haven't taken the effort. He shows the tubing markings. Reel and Wade, a coil hose company, nylon 6 millimeter OD by 4 millimeter ID, which means 1 millimeter wall, 340 PSI at 775 Fahrenheit, extruded in the USA. Word of advice, don't pick 16 millimeter OD, 12 millimeter ID acrylic for your first hard line build. No links, but it was a bear to get everything sized properly. I bet. Okay, so we can read the text that way. That's how we're going to put it in. That is all away, and pull out on that, and that should be sealed. We can read the text that way. All right. There we go. Approximately the same length, within a very close amount. It said it didn't matter. Before performing this next step, it's important to clean any residual dust and or machining oils from the back of the idle cooler plate. So it's going on the back here, okay? Isopropyl alcohol and acetone are great for this purpose. Please use gloves, long and eye protection. Be sure to remove the plastic protection. Deposit a pea-sized amount of the thermal compound to the middle of the copper face of the water block. Install and secure as shown using 4 M3 by 20 socket heads. 4 M3 by 20 socket heads. That's these guys. What do we got? 13 minutes. We need 79 likes still. Can we do it? Need 79 likes in 13 minutes. My very first water cooling system was a thermal take, big water. Used 8mm by 5mm silicone tubing on my Milo build. Like something stiffer. Yeah, this is relatively stiff. Are the fixings mixed metals? The fixings mixed metals. What do we mean? What are the fixings? We've got, looks like some stainless steel couplers, an aluminum block, and a copper. We should be able to do it almost 300 people on right now. That's what I'm thinking. Maybe print a heat shrink label to mark hot cold water for tubes. Vanic corrosion alert. Well, the coolant we can fix with that, right? You use a coolant additive in the coolant for that. We should have at least 394 likes. The amount of viewers, 397 now. Okay, so these are going to go here and then thread in there. So let's see how this. So this goes like this, and this is going to go right there in those holes. Should use same material for the water cooling. Okay. So are you saying that all of these fittings in any water cooling setup are aluminum or copper, and all of the blocks are, I mean, blocks are always going to be copper. So I don't get it. Is this really a thing that use same material, but do they make copper or aluminum fittings here? Fittings are usually brass. Okay. Can you resolve this with an additive in the coolant? Blocks aren't always copper. Okay. These are stainless steel fitting. Then this stuff, I hate this stuff. You can't resolve it? So am I wasting my time? That's my question. Am I wasting my time? Okay, so I'm going to pull this off. Oh, I need to clean that. I know I'm fine, Poity. What I'm getting at is there can be, this is one of those things that can get really, especially in the PC modding and water cooling community, can get a little out of overblown. Can get a little overblown. You can fix this with additives. They do it in cars, right? All of the coolant passages are not the same materials. You do have to service a car as well. Sure, that's absolutely a valid answer. Service it more often. But it's one of those things that you, especially in the mod communities where if you don't do everything exactly right, it's just not going to work. Distilled water with additives, corrosion will take ages. Exactly. But the immediate, oh, it's not the right materials. That's kind of annoying. It's not all the same materials. It's not all perfect. You're going to get galvanic corrosion. That, think about that. Additives will keep you safe for a few months. Bull. It's going to be more than a few months. Difference between not the best option and not workable. So, sorry, I'm getting a little... Yeah, TechEd, delete that. It's not productive. Oh, geez. See, I hate this stuff. I hate this stuff. Ew. Only needed a tiny bit. Anyway, I'll check a few, you'll see the downsides. Rodney. Okay. This goes on here like this. Is that buying one for mine just because the cooler plate here? Oh, shoot. I just slid right into making a mess. I have 4 minutes to get 49 likes, but it sounds like I probably instituted a few dislikes there. Induced, whatever. Trying to make this somewhat centered on this block, I guess. There's a screw right here that I'm a little concerned about. So let's put it this way. Dissimilar metals, sure. Is it actually a problem? And if it is, what is the mitigation? It's just the attitude that coming in of it's not right, don't do it, is what I'm trying to stay away from. If somebody has a cost-effective suggestions for alternative parts to make this more proper, then I would welcome the suggestions. I think KB3D would welcome the suggestions. You're adding another point of maintenance, which if it isn't done, then a point of failure. Yeah, sure. Is there any setup here that would be maintenance free? Let's put it that way. Is there any setup here that would be maintenance free? Is that an expectation? Is maintenance free an expectation? And when I hear the problem is going to occur in months, then I got a call. No, it's not going to be months. If one metal aluminum makes the most sense to be maintenance free. After 5 years, it's time for a new controller board anyway. Change simply fitting, same material. Well, identify them. Tell me where to get them. These fasteners should be tightened uniformly and without high torque to avoid warping the cooler. And I didn't tighten them very tight. I can't see a point to liquid cooling this part in the first place. Last tool head isn't going to be getting any benefits. Apparently it does. That is a good question. I agree. This is a long ways away. It seems to be effective. We'll keep an eye on it though, because I think that's a valid question, very valid question of how well does this cool as it comes across this plate. So what I do at work, and we have 25-year lifespan with no maintenance. We revisit this in 6 months. So what am I looking for? So let's go this way. If I'm putting this together as it is in its flawed, completely messed up state, then what am I looking for over time? Is it something I can see? Is it something, how do I monitor that? The plate is aluminum. This plate is aluminum. The VZ-Bot doesn't have water cooling yet. I have all the parts to water cool, just the hot end. Furthest you are from the cooler, less efficient the cooling. Yep, I agree. I'm curious if it's going to be an issue or not. Degradation of the metal, not smooth, dimpled. You have to send your coolant off for testing. If your coolant looking nasty and bits floating in it, okay. Flaky stuff, small chunks. So stuff we can see, somewhat. Yeah. We are at giveaway time. We did not hit our 300 like goal, but maybe we can hit it by the time we're done with the giveaways. So the buildup corrosion would affect the thin fins inside the block, either blocking the fins or corroding them. I'm not saying you will have a problem, but you would look for corrosion or nasty cooling. Cool. I'll keep an eye out. I will keep an eye out. So I apologize, everybody. They are valid concerns. To what degree they are is a question, and that's really what my question is. Is it really a problem, or is it just one of those things? So, can't directly compare to automotive due to the scale. The fins in the block will clog orders of magnitude more easily. Ugh. Giveaway. Links are in the description because there's 2 of them. So, giving away some hot sauce and a roll of Polymaker filament. So, I'll just speculating here. Those fittings may already be nickel plated and cause 0 of the speculation issues. That's I don't know what they are made of. Nice. Thanks for gifted memberships. Galvanic corrosion needs a medium that allows change to flow. So if the printer is wet, especially with something like salt water, you'll see corrosion. Just finished wiring at the Z-axis. It's honestly not a problem because how often do we see this in obvious computers with the dual metals? It's just recommended to service it more often, like people have said, and you look out for corrosion. So I reacted. So here I reacted to just the "it's not right, it's not going to work" attitude, and I swung completely the other way to begin with, right? Pushing back against that. So we'll keep an eye on it. We'll do it as proper as we can, given the setup, and we'll go from there. Okay. So giveaway. Let me bring up the wheel of names. It's all about the fittings. Can't say I've ever seen an aluminum fitting. They're always made from a sturdier material. I don't think it's the fittings. It's just the setup as it's designed. But okay. I am going to close the Pex Peppers giveaway when we haven't had a new entry in 3 seconds. This first black box has been built. This design has been around for a very long time. Yep. In 3 seconds, we just had one. So 3. This is all engagement. This is true. I'll get a spike in the chat log. 2. The only reason I even worry about overheating is because it's cooling 200-degree hot ends and not thermally locked. Get me some hot sauce. These fittings are indeed nickel plated. Thank you, Chris. Thanks for coming in. The loops consist of copper, nickel, and plastic. Well, maybe not ideal on paper. So oh, is that not, that's Delrin, isn't it? That's not aluminum, that's Delrin. Is that Delrin? Well, maybe not ideal on paper. We confirm that a 3.5-year-old loop still shows no sign. Thanks, Chris. Hey, Steve, I can't post a link, but at the moment your coupon code is automatic and it takes off 35% site-wide. So Steve builds. First time I played this game, Nerd Fights. Looks like Palm, aka Delrin. Yeah. We're actually only cooling what makes it past the heat break. It's a very low wattage equivalent. Diffuse tabs or space. Yeah, you end the sentence, begin the sentence with 2, or end a sentence with 2 spaces. Is that the thing? Automatically applies 35%. All my PC water blocks are Palm. Okay, cool. We've had a couple new, so we'll start the countdown over. 3. So all this argument is null and void. So I honestly, I thought that was aluminum looking at it. I should have looked closer. That is Delrin. Those are nickel plated, and it is a copper block. It's okay. I reacted the other way too. 3. Nice. Thanks for becoming a member. 2. 1. Half. Quarter. 1/8. 16th. 32nd. Done. Okay, this is Pex Pepper hot sauce. Said it was aluminum just to get people going. I didn't. For some reason, I assumed it was aluminum and I didn't look close enough. My bad. Dan, thanks for being a member. That's also a good point to not over tighten, especially if that's not aluminum. Aluminium. Okay, Brian T got the first entry in, and Frank got the last one in. What store has 35% off? PexPeppers.com. PexPeppers.com. Delicious hot sauce. PF Dennis, thanks for the gifted memberships. Okay, we are going to do a number between, I don't even know. Today is 5/19, between 5 and 19. Nuances of scale between different automotive and the fact light is being able to get very different. Second turn for galvanic corrosion will be radiator. What did I say? Between 5 and 19. 6.9. Let's go 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and spin. H. John, congratulations. H. John, you have won a bottle of To the Moon Harvest Edition. Oh. What? Oh, I thought I was sharing it. I'm sorry, people. I'm sorry, folks. H. John, you didn't see the spin. I know. I'm just too caught up. H. John. The wheel got corroded. H. John. I don't like when I get annoyed like that. Not annoyed, that's not the right word. H. John, are you around? You have a minute to respond. We're doing 2 of these, apparently. We are doing 2. We're going to do one right after this, so... H. John, you're here. Awesome. We're doing 2 of these because we didn't see the wheel, and Garrett said to do 2. Flustered. Yes. Thank you, Phil. And it's a reaction to the extreme, or my perception of what was the extreme. Because the way it came on was, it's wrong, it's going to corrode. Okay, but what degree? Anyway, we're done. We're going to move on. We are going to roll between 1 and 10. Just get this moving. About 50 people jumped into chat at that moment as well, which excited things. This is true. 1 and 10. We are rolling another. We are rolling another because Garrett's cool and nobody saw the first roll. H. John, congratulations. Let's go 5. 1, 2, 3, 4, 5. Spin. Who do we got? Who do we got? Nellis. Canalis. Is it like Knipex? It's Canalis. Congratulations. Are you here? You have 2 minutes. I got dramatized. Yes. Canalis. Are you here? Congratulations. You have 1 minute and 30 seconds. How long is the code good for? Usually end of stream. Concurrent. Canalis. You have 1 minute and 15. Are you here? Yep, end of stream. 4 a.m. and the baby has slept through. Nice. This is a bottle of To the Moon Harvest Edition. It is spicy on the 7 of 10 on the scale. And this is roasted, like the Pueblo Red. Is the difference. The peppers, habaneros are roasted in here. Is that what makes it the Harvest Edition? It is also on sale right now. $6 a bottle. Fire roasted the red habaneros in this sauce. You have 30 seconds, Canales. Nalis. It's in the nuclear category. Probably a bit much for me. Dirty Jobs the other night had pucker butt peppers on there. 3, 2, 1. Siri is trying to activate. I don't know why. I turned that off. Okay, we're gonna roll again. Sorry, Canales. You are a member. We haven't had a member to the Polar Ted Club in a long time. So we're gonna reshuffle the same. 1, 2, 3, 4, 5, and spin. We got a new member to the Polar Ted Club. Who do we have this time? Who's the new member? R. Chapman. I recognize that name. Are you here, R. Chapman? You have 2 minutes to say something. R. Chapman. Are you a spicy hot sauce fan? R. Chapman. I imagine if you entered, you're a spicy hot sauce fan. What bundle would you recommend for a variety? What is that? Oh, nice. That's interesting. That showed up on my OBS screen before it showed up in actual YouTube chat. Thanks, nice. I just realized I was no longer subscribed after my credit card change. Oops. Anything that is 0 out of 10. Pueblo Red is pretty mild. It's not 0, but it is. I don't like hot sauce. I don't like spicy hot sauce. And I really like the Pueblo Red. I don't know if there's anything lower than that. Pex Peppers can respond. R. Chapman, I see you. Congratulations. You are the second winner of that. Okay, polymaker filament. Let's close this and remove these. And we are going to close the polymaker filament form in 3 seconds. My toddler likes Pueblo Red. I saw you, R. Chapman. Congratulations. We are going to close this in 3, 2, 1.5. 1. 15/16. 9/16. Wait, what? Wait, what? Oh. We still haven't had one. Oh, there. We just got one. So 3, 2, 1, quarter, 3/64. Oops, I got a thing here. We just got one. 3, 2. Did we hit 300 likes yet? Almost. 12 more. We need 12 more likes before the giveaways are done. 2, because we didn't get a new one. 3, 2, 1, done. Okay, who got that last one in? This is Iowa, and she won't touch Heinz ketchup anymore. Nice. I'm almost done with this level. Brian T got the first one on this one too. Who got that last one in? It's Shammy. Shammy got the last one in. You just missed it. You were expecting an extra. We've been going for a while though. We've been going for a while. Where is Steve on the ADD scale? Okay, let's do a number between 3 and 25. We only need 3 more likes. Just got back from building a shed foundation. Mine took like 9 months. If you just got back from it, you're way ahead of me. What did I do? 3 and 25? Is that what I said? I like 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Spin. This is Roller Polymaker Filament. If you're in the US or Canada, it's a coupon to the US or Canada store. If you're outside, then you get to pick from a form. Olsen Zeiss, are you here? Congratulations. You are the winner. Olsen Zeiss. If you're outside the US and Canada, you get a long form, a pick from a long list of filament for a roll to be sent to you. Olsen Zeiss. One more? What are we up to? 299. So we need one more before Olsen says something in chat. We got one exactly as Olsen said something in chat. Congrats. You 3 winners today will get an email from me sometime between now and before next stream, because that seems to be the trend. I do it right before the next stream. Okay, congratulations. Congrats. Oh, you had some time left, so that's all clear. Go, there we go. Okay, back to the build. Unrelated question, how do you comment, uncomment selected text in a printer config? Control /. If you have your cursor on the line, it'll do that line. If you highlight multiple lines, it'll do all of those lines. But Control / will do it. I'm gonna unpin. Get to that before somebody can remind me to unpin. And clean up the... Mixing aluminum, copper, and go. Let me clean up this, and then we're on to the next bit. I guess we get to bring the printer up here. And while I'm here, let's delete that for next time. Here, so, okay, so that is all done. Install 10 M4 T-nuts into left upper inside extrusion as shown. Working with the entire toolbank subassembly, capture each of the remaining tool dock subassemblies using M4x30 socket heads. Hey, Necrogamy. It is going okay. It is going good. I guess here? This is all twisted up. So this guy can go over here. That can go over there. This I can put over here. And the left side. So let's grab it from here. This is not a light printer. What are we on? Okay. This there, try to make it not the focus. Okay, seriously, a rig that uses a pump has 2 metals and uses salt water, and then how long until it fails? There's your worst case. Put Stefan on it. Okay, M4 3030s. So we got you down for a hernia. Can you tell me again what it was you were lifting? So these are gonna go, this is the left side. Basically gonna go here. Now I have no idea why I put these in the top. There's some of these in the top extrusions. I'm gonna snag them. I don't know why they're here. Okay, maybe I won't. Check out stream Discord chat if you want to see something awesome. Okay, let's see. Stream Discord chat. Stream chat. What is awesome? Ooh. Meteorite passed over and crashed in Portugal last night. Whoa. Is that real? That seems awfully staged from the... Were they already videoing? How do I... Here, let's download that. Save. Open. There we are. That's interesting. Is that actually real? You got bright, they need more amps than the board is rated and you want to dim it. Only a bed MOSFET or similar will warm up brutally. I don't know. There's going to be CNC tool head on this thing. The extra amps damage the board. Did they already have music playing? Yeah. That's kind of cool. It's real. Dozens of vids on... Oh, cool. Live streaming on TikTok and happen to catch it. That's lucky. Okay, where are more of these? Let's go here. And they don't know where it touched down. I mean, it hit, and they don't know where. I got 10 of these to put in, all in what appears to be this orientation, is what they're saying. Oh, I thought someone said it hit the ground and crashed in Portugal last night, is what they said, but it doesn't. It did it or did it not? Impact was unconfirmed. Okay. Oop, wrong way. Wrong way. Come on. There we go. There's an alien ship. First contact. Okay, 1, 2, 4, 6, 8, 2 more. Most meteorites disintegrate before they hit the ground. Yep. Okay. Where did I put the thing? What is the spacing on this? This thing goes in here, like this. What is, I guess I can go probably something like this and just space it. Does it go all the way to the side or? Just get these placed approximately. And this is gonna just, there's no way around. We'll go, oh. Just so you're not staring at the back of my head. Hoping I can just put it in loosely and then shift it back and forth. Yep. That is what I see what you said there, Chris. There will be a spacer block. Hey, Luke, welcome. If they have several angles, they can triangulate the path and search for debris. Yep. There's a printed tool for spacing. Is that what this is? I don't know. Does it say in here that there's a printed tool? Working with the entire tool bank subassembly, capture each of the remaining tool dock spacer subassemblies using 10 M4 by 30 socket heads. Is that these guys? Yep. 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Board member in the local astronomy club. We have a nationwide setup for tracking meteors. One station is on our roof. Nice. Okay, so we need all of these. We're gonna go in here like that. Can I just set these things on here? What if I just put these in here? Then I can set that on there. I can line those up. So what if I do that? So then that'll go there. Then the next one will go right next to it, but I can just leave that up there, right? And realize that I was way off on these anyway. Next one, go about right there. Oop. In Norway. Oh, okay. I didn't see it, unfortunately. Green flash in the sky. Let's go this way because, once again, back of the head. I'm just going to grab all of these and put them on just like this. I can. Seems to be about the spacing. Let's see how easy that is or not. Now this can go up here with these in place. So can I, oops, put that upside down. Make sure they're lined up. Okay, that's gonna go there. Those sitting like printed T-nuts. They're not really, they're more to just kind of align the piece in the extrusion, I think. So there we are. And reach behind here. Oh. I think I can thread that in that much, and I'm hoping, ooh, got it. I'm hoping this still leaves me enough play to slide the rest of them in one at a time. So that's on there. Quick clamp time. No, because I need the space. I need to be able to slide it out. I think right there is where I'm golden now. I can just kind of hold this up and put each thing in now. So all of this is loose, but I can start setting these. Yep, nice. I just posted a couple of links to the Desert Fireballs network about how they track the meteorites. Nice. They are keyed. Yeah. This is not as, once I get past those first few, this is a lot easier than, this isn't bad. That's what I'm trying to say. Right there. My grayscale box. A grayscale box instead of black box. Last one. Yep, cool. I think that worked out pretty well. And this whole thing can shift back and forth. Let's figure out where it needs to shift. A second view of the fully assembled tool dock ready for installation. Move each T-nuts to its estimated final position. Loosely fasten the sub-assembly to the frame using the two far corners first. I don't think there was any good way to hold these things all together like this. Loosely tighten the remaining 8 fasteners. Locate the printed dock tool here. Gotta go here, folks. Gonna watch the end of the stream later. See you, Derek. Oh, I was really close. I was within a millimeter of the right spot. I wonder what it's actually supposed to be. It's gonna be fiddly no matter what. I feel like on the fiddle scale, that was pretty low. We've definitely run into fiddlier. I'm gonna open up Fusion. So let's give this a second. Is this going to switch tool heads in the same manner that a clicky does? Such and such location, enable tool head and whatever. There's a little, basically, but there is a little NEMA 8-stepper motor that actuates a locking mechanism to grab the tools. So yeah, it's basically that, but it actively grabs and locks in onto the tools. Okay, let me bring up the Blackbox file. It's gonna open it up. It's gonna open up here. What exactly is the water cooling for? So the water cooling is so that the tool heads that are docked stay, you don't have to have fans. You don't have to have active fans on each tool head. Update later. So if we go in here and look at, here's our water block, but I want to see the distance. So to measure distance from that surface on the side of that block over to the side of the frame is 33 millimeters. So my part here, let's see how well this turned out, is 27.8 millimeters. So what, are you still here, Chris? Because this seems really, really off. It's basically 28 millimeters is what this is saying, but the CAD is showing 33 millimeters. What's your opinion on having the hot end and extruder motors separate rather than there's multiple full tool heads? Space, I think, is the biggest thing here, and cost. You don't need a separate, you have one extruder motor. You would need 5 extruder motors. Looks like Chris is checking. Thought the NEMA 17 was for the tool changer. No, while we're waiting for that, the NEMA 17 has this little IGUS drylin or whatever. What's their filament? It's a 3D printed part. It's not a FDM printed part for the interface between the NEMA 17 and each tool head for extrusion. And then it has a NEMA 8 here to actuate this little, oh, you still can't see it, little part here for locking. Yeah, so then the tool heads, since this is all water cooled, the tool heads can stay at a dock temperature, because usually you'll lower them a little bit to be on the dock, right? But they still keep from heat creep. Now the question before is how effective this is. It's effective enough that there's lots of these printers running. You may have less cooling and the end tool head than this one, but Chris was saying something about the actual wattage that needs to be dissipated on here is fairly low anyway. Five step sticks or whatever, not just the 5 motors. Yes. Will you work on the Milo CNC again? I probably won't be covering it on stream, but things that I make on it will be covered. Your machine sits at like 28 millimeters. Okay, and it works. So, and your machine is what the config is based off of? Because this is gonna be close at least. I know we need to set all of those, but this is, oops, 27.8, or well, yeah, the whole thing there, right at 28 millimeters. So we'll just set this here. Should I just set it where it's at then, since I'm really, really close? Or should I just move all of these over? My machine was the basis for the base config, but these values always need tweaked. Yep. They need to be tweaked anyway, right? So being at least in that ballpark is going to be good enough. So with this here, we are right there now. So I'm at 28 millimeters. So that's what we're gonna go with. What do you plan to make on the Milo? So I've done some work on this printer on the Milo. The big project that I've been wanting to do on the Milo is the machine parts for the Tic Tac build. That is the big part. Okay, so I'm just gonna, I know there's lots of tweaking that still needs to be done. I'm just setting these in here, kind of like that. Steve pushed by the block, not the printed parts. On what? Yeah, I pushed across the blocks behind is what I was actually pushing on, is back here. I wasn't pushing on the docks. This machine is designed to be a workhorse with long hours between services. That's the hope. Now, I'll line these up with each. And I'm not tightening these a lot. I'm just getting things snug. Snug and level. Hey, Joseph. Nice and solid. So loosening these screws here will allow us to shift the position slightly of each dock to align with each other. And then of course the brush assembly here. I think it probably needs a little bit of tweaking and playing around to get everything lined up. But let's see where we're at in the instructions. Place the printed tool between the tool blank, slide the tool, we did that. Fully tighten all the tool blank tools. Finally, fully tighten all the M3 socket heads that secure each nozzle wiper assembly, and then remove that tool. You have completed all the assembly of the tool dock. Woohoo! So while we're at it, let's go ahead and go in here and let's go ahead and tweak some of these. Let's loosen all of these a little bit. So are you still there, Chris? Should all of these be tightened against each other, or should there be a slight gap between the docks? Is there any gap at all? We do ship to the EU, send more machines to the EU over the States. A slight gap is correct. Is there like is it a 1 millimeter gap, or should it just be whatever is even? I feel like this. Let's see, things kind of, it looks good. You'll adjust them a bit later. Let's go here. Okay. We'll adjust them a bit later. I won't spend a ton of time on it today. I want to pull on that pin. Feeler gauge would work nicely. Yeah, agreed. But we'll if we have to adjust it later, I'm just getting them somewhat even, although I'm missing the mark on this one. That'll all need to be tweaked. OCP, exactly. Thank you, Tuxedo. Shush, Hacker Jack. Shush. Here. Okay, we are done with guide 6. Close that. Remember, through the end of the stream, Steve Builds is a coupon. Get rid of that. And guides. Guide 7, FDM tool. I think we can move this off to the side now. Guide 6. This is an exciting one. So the hope is to get through 1 or 2 of these today, and then I'll finish the others off stream, and we'll come back next stream and do electronics installs. So let's go zoom in a little bit. So we have heat sinking paste, and stuff. So assembling your FDM tools with precision and care will lead to long-term reliable tool changes. That whole table flexed when the printer was put down. This table, it's not gonna fall, but it needs to go away. It's a Craftsman little, it's supposed to be a little table you can put tools on and use them. It has a lot of play. It's not flex, it's the top has play, see? But it doesn't move beyond this. It's stable beyond that. Crimping stream. Okay. When compared to the rest of the machining, accuracies in either geometry and assembly can result in significant effects. I need a pooch table. I need to make a little portable table that can serve that's on wheels. Okay, main body preparation. Locate printed part 3. I think all these printed parts are over here. I have only printed enough of these for 2 tool heads. So when we get 2 tool heads done, we are done for the day. Now look here, Steve, did you do the print test? Of course I did. Where'd I put it? It's around here somewhere. I did the print test. So these are the pieces. When printed in the correct orientation, the filament path is a vertically printed hole. Run a 2mm reamer through the filament path shown below. So that is here. So I was playing around with this. I tested a piece of regular filament. Runs through it okay. What I wanted to try is some carbon filament here and see how it does. I have some carbon. I'm just going to cut off a piece. Piece of carbon filament here and see how it does. Oh yeah. I'm just gonna run that through there. And I've seen a bunch of people just use abrasive filament instead of reaming. I was doing this before I saw your comment there, Josh. But it fits really well. Let's see how this one does. There we go. So this is carbon fiber PLA from the Magneto X. I think we will be good. Okay. Insert M3 heat sets in the following locations. Now these are the parts that I did fix. So all of these are correct diameters for the heat sets. Oh, how are we doing on, how are we doing? How many people stuck around? How many people are, still have 250 people, that's good. Okay, we have a bunch of heat sets to put in here. So if this is, okay, so there and there and there and there and there and there, and maybe on the back. Who's still here? Who's paying attention? Let's see how many people are paying attention. Got every printed for my next Voron build, just waiting for my new Pi to get here. Awesome. Okay, heat that guy up. How much attention? Any attention. If you can type in here, then that's enough attention. Hey, Deanna. I overslept, so here late. Lost my chance to lose the giveaway. We did get someone to enter the Polar Ted Club. That part is going to be 5 pounds just from the heat sets. Don't do the giveaways, but always help the likes and lurk. Thank you. Here they are. Do what now? I just want to see who's paying attention. Here? We are not paying attention. It wasn't me. I don't believe you. Ow. Huh, that's interesting. So, are these, for some reason, so I might have screwed up. So I might have screwed up a little bit. I might have screwed up. Yeah, that pulls right out. For some reason, I had it in my head that these were the same spec heat sets as we use in the Vorons, but they might not be. I got a fix for that. Those are 5 millimeters. These are 4.5 millimeters. So they are different. So that was my bad. I made a mistake. So I'm gonna fix that by just putting Voron size heat sets in here. But I screwed up. Busy measuring Milo Mansion for panels. These are M3 by 4.6 by 4. And that is my own. Poity is laughing at me. I did. That's okay. I'm gonna have to go back in and fix the parts, Chris, because I edited them. Yeah, those are going in a lot. Okay, so we are going to pull all these others, and let's see if they just, yep, they just pull out, so that's good. We're gonna pull these and just substitute in these. Those not the heat sets. These, so here, I have been going in and doing my OCP thing. Here, let's see here. I have been going in with these parts and quit blowing holes in my ship. I have been going in and cleaning up some of the things in the CAD. So on these parts, or these parts, there are a lot of parts where it gets printed, there is a small fillet there instead of a chamfer. So I've been going in and replacing those with chamfers. You know, little things. Not game breaking. It's 0.4 millimeters. A fillet is probably going to be okay, but I'm doing my thing. In these latest parts, I decided to go in and clean up the heat set size. And I had it in my head that we were using the same size as the Voron heat set. So I made all of these 4.7 millimeters in diameter when they should have been like 4.5 or 4.4, whatever it is for these, for the heat sets that came in it. So I need to, basically all that means is I need to replace the heat sets on these parts with the Voron size heat sets. And that will get us past this. But to go, thanks for see Andres. So yeah, that's on me. I was running through the things, getting ready to print them, and I had the wrong size. So let's see if these will just pull out. Yep, they are. So that's definitely the wrong size. That's why they went in so quick. And I really noticed it on the side ones. So the Voron size, the size that we use in Voron for heat sets, is not any kind of standard. They're actually kind of large, larger diameter for an M3 heat set. I think more common are these 4.6 millimeter diameter ones. So, but this is easy. So my train of thought, why I got here, is that all of the holes for the heat sets have been too small coming through in the design so far. So I figured that, oh, these must be for the smaller ones that are out there. They must be for the extra smaller ones that are out there. So I figured they were for the smaller ones, so they must be actually have included the Voron size one. So when I went in and did the parts, I modified them to fit the Voron size. There's one on each end here. Yeah, one on each end. So that's how we got here. Where can I find your heat set press? Search for Vector 3D VLMP, Vertical Linear Motion Press. Are you done laughing, Poity? Just curious. Can anyone tell me what to look for if I think my pie is done for? What are the symptoms? My last troubleshooting of a pie was my V0 it failed on, and I ended up just putting the SD card in another, it was a Pi 3, putting the SD card in another Pi 3 and it came up just fine. So that's when I knew it was just the Pi. But if you don't have the luxury of having a second Pi to try, okay. Oh, one more. Two more. Nice thing with a properly sized hole is there's no squish out. It just melts in. There. Okay. And then there's install the embedded Bowden coupling. So I'm guessing that's in one of these. Yep. So in the FDM hardware kit, I'm trying to get it to work on my new Trident build. I thought it was the SD card. I changed the SD card into another Pi and it would not work. Use another SD card and still no work. I would try reflashing it then. It might be the way it's imaged. So there's a little brass coupling. Oh, there it is. Little brass fitting in here. This way. This guy. How does this go? Does the tip of the iron prevent smush filling the inside of the insert? No, it does not. Okay, how does this guy go in? Is it the install the embedded Bowden coupling? Be sure to take note of its direction in the image below. The bottom or inward facing portion of the insert has a chamfer feature. Okay. Here, let me grab two of these so I can show. Okay. So we got one that way and one that way. I don't know if you can see, but this is the bottom because it's kind of tapered in there. This is the top. And what I think the whole purpose of that is this guy goes in and clips on the inside of that chamfer like that. Okay, so that goes there, and then this goes right in here. Now the question is, do we heat that in there? If seating is difficult with the tools at your disposal, it can also be treated as a standard heat set insert installed that way and installed that way. Do I have a heat set tool that's that big? Oh, I do. I have a big heat set tool. Is this one that'll work? Now the question is, that sticks out quite a bit. I don't want to melt the plastic behind it, so that's probably not an appropriate method for doing this. What might be better is to use the too large of one and push it just from the top. And I don't think it's going to need to get all that hot. So. Ooh. Yeah, that's hot because it's still on. I didn't unplug it when I put it over there, so when I moved it, it started heating up, and now it's hot. This is why I need two of these. I need one that can be cold that I can swap out easy, and the other one that has M3, basically. Smell bacon. I'd like to use that. If I can use this, probably be a whole lot quicker. Is that this guy? I think that's this guy. Yeah. Just put this away over here. Bump. Oh boy. Ah. That is a big heat set tool. Let's turn this down a bit. I don't need it to be super hot. Let's get this right here. This guy. I could probably use my Knipex pliers and press this in here, but I don't want to risk splitting the tool. So I'm going to do my best to press evenly on the top of this. Yeah, that is going to work okay. Straight down. Does that go down to flush? You around, Chris? Does that go down to flush, or is it just slightly over flush when it's fully inserted? If the answer is flush, then we're good. If the answer is over flush, then I went too far. Four-hour stream brain. Where are we at? What time is it? It is only 4 hours. We're doing awesome. What filament is that black? This is Siraya glass fiber ABS. Siraya glass fiber ABS. Okay, so that's one. We'll go ahead and do both of these. Making sure it's the correct way up. So that's wrong. You see the chamfer in there? So the thicker, it should look thicker from the top. Yeah, it's nice and even. I don't see any, I don't think it's squishing out anywhere that matters. Yeah, looks right. Welcome back, Bruno. Turn off. Install. When fully seated, the insert will be flush with the printed part. If I would have read the whole thing, if I wouldn't have gotten caught up in too many words. So it's flush. Install the Bowden collet and clip as shown. Okay. Let me make sure these are cool. So the Bowden collet will then go in, and it goes, it seats in all the way, and the clip. Clip. Those remind me a lot of the CW2 blocks. Well, it is all BMG based. Bondtech BMG based. Locate and install an MR85ZZ bearing into the bottom pocket as shown. Be sure the bearing is fully seated. Note that the plastic behind the bearing is in the thinner side. For this reason, it is advised the bearing be pushed into the printed part via its outer race. Simple, okay. Okay. I can do that. And then this step requires mechanically removing and replacing the standard 51 tooth gear from the main 5mm Bondtech drive shaft assembly. Is that 51 teeth? I always thought that was 50. Okay, let's go here. So we have this, and then we have bearings in here. So let's grab one of these bearings from there. And right there. And can I fit? Ooh, Nipix pliers fit right in there. I think that'll be about perfect. So if that guy goes in there. Let's get that kind of wiggle it to try to get it into the part. What hot ends will those tools have? They'll all be Revovorons. With Mirage C's research on dual gears, do you think it would be worth testing a CW2 with a smooth groove bearing guidler instead of the second gear? Maybe. Okay, so I've got a spot that I had actually, let me clean this up. I need to pay more attention to how this is. Oh, actually, let's clean this up with my Noga scraper. So I had deformed the plastic a little bit around the edge here. There's a little spot in the corner here that could probably be cleaned up for little stringy. Okay, so now this is going to go in here, and what I want to do is try to get this on so it is centered. Yeah. There we go. A little chamfer always helps, yeah. I feel like the Revo is a really good choice for a printer like this, just in the flexibility of being able to swap out the nozzles, sizes and types and stuff pretty easily. So I'm going to go in here and just proactively scrape along the top edge there and get where the seam is. The seam is on this outer edge. There. If I look from the top, I can kind of tell if it's going in straight or not. There we go. What filament on those black parts? These are Siraya glass fiber ABS. When I run out, I only have one roll of the gray and one roll of the black. I'm pretty much done printing gray parts, I think. But when I run out of black, I've got some glass fiber ASA that I'll end up using. Okay, so that is done. Now we're gonna find our gears. So do we have, did these come? Yes, okay. So where are those for that baggie? Because I pulled them out. There they are. Okay, so this is the Bondtech gear stuff. I have a roll here of glass fiber ASA to try, but haven't had the nerve of it yet. Yeah, I've used 3DO glass fiber ASA, and it's great. It's awesome. I'm sure this this Siraya stuff is printed great. So, okay, so we got to take this gear off and replace it with this one. So, this is saying that there's a few ways we can do that. If you have removal options, you can use a press. If you have access to a press with a pass-through functionality, you can simply support the gear at the shown locations and press the shaft downward with suitable driver and out of the gear itself. And CFL. Or you could cut it. You can cut a groove in the plastic and pull it away. And then we press the thing on. I have that. Ooh, that might work. I don't know where it is. I honestly don't know where it is. I have the puller that I used on the Ender 3 steppers. I don't know where it is. So I think I'm just going to use my vise. I'm just going to use my vise here. And I think I can grab a 4mm socket. Yeah, that'll work. And for pulling this, there's no reason that I can't just do a socket there and press it that way. And then there's splines in here. So I think it should just come off. I could do it this way with a deeper socket and a pin of some sort. Let's try both ways and see what happens. Let's try both ways and see what happens. Could tappy tap it. Yep. Make sure that's somewhat centered. And should be able to press that through. Yep, it pulled right up. Let's see if there's splines on there. That worked really well. I don't think we should do any other way. Because what basically happened is I got to a point where this was bottomed out in this socket. So, and now that is So that guy, and we got to do this to 2 of them. Let's grab one. Where's the other hardware kit? There it is. This one here. Cut the gear, teach it a lesson. What if I find a use for it later? Oh, why is there a grub screw in there? Was there a grub screw in the other one? What's the other bag? Let's just put that in there. I've got plenty of screws. Since this worked so well, I'm just going to do it again. I was worried that it might still be a friction fit across the whole thing, but there we go. I've melted or ground a few of those. Good spares. Yeah, it could be useful. That's the trap we get into though, right? Okay. Cut one so the others know not to mess with the steel. I'm burying my keyboard here. So we now be installing the new SLS printed gear. So onto the shaft. Note that the SLS printed parts have a larger demanded tolerance allowance than FDM printed parts. For this reason, some driven gears may require reaming, whereas others may not. Always attempt installation before removing any material. Yeah. I feel seen. Don't throw out anything. Exactly. It's like some keyboard. Begin by starting the engagement of the driven gear onto the shaft in the following orientations. Note the crown of the driven gear has teeth that protrude past the surface of the face of the gear. Yes, they do. I think that's so it aligns with the other one. Kind of self-aligns. If the gear cannot be started by hand, a chamfer can be added to aid in this. Alternatively, you can move on to the next step using the printed tool as the printing surface. Locate the printed gear pressing tool. Did I print that? I don't think I printed that. I printed all this stuff. Huh, I don't think I printed that. I printed, these are tools that are coming up. But I think I missed that. Okay, so this is here and this goes on here. Now, what is the consequence of if that is too tight? If that goes on, yeah, that goes on there. So without too much fuss. Yeah, I'm going to reuse the socket. I think I'm going to, let's do a quick, just get that started on those splines and see what it looks like. Making sure that I'm going to edge up on this to try to stay square, and I'm in the middle of my vise here. I could make this easier on myself. I've folded over so it fits in my workbench there, but middle of the vise. Yeah, this'll work. I don't think I have to adjust these at all. So we'll go just there to the bottomed out. So now it's flush. Don't press on the gear, the teeth outside. Yeah, this is a flat surface here. I think this was a flat surface. I think we're okay. Let's see if I have a better solution than that. Okay, this one will work. This is a 7/32 socket, but what I'm looking for is one that fits with very little play. That way I'm pushing right on the inside of that right there. The old gear was a good point. Good choice. Old gear would be a good choice. It is not really a press fit on there, so that's not a bad idea because I can kind of hold it parallel to. Maybe I'll do that. I like that idea. I am going to flip it around this way because this way I've got some potential for deforming things, I think. I like the old gear idea. How far on does it have to go? Squeeze with a large pair of pliers or a bench vise. Hammer time. View of correctly installed. Does it say? Give me a measurement. Come on. Does it give me a measurement somewhere? Good thing you didn't cut. It still could have been used if it was cut, if the cut was clean. Okay, we're gonna go on just a little bit then, just to start. So I think I can hold this. Okay, so get it. Until the serrated is buried in the gear, I guess. Yeah, that's kind of where I'm starting. Let me open up. I'm gonna hold on. Give me a minute. Give me a minute in Fusion. Give me a minute. You need that printed part by the looks. I don't need the printed part. We can measure it. What is that thing called? This is guide 7, FDM tool, tools. Oh, there isn't a tool for that. There isn't a tool in the STL, so you're around, Poity? There is not a tool in the STLs for guide 7 for that. Let's see if I can find it. Z-axis pulley. There it is. There we go. Okay. So this is the tool. This is not in the printed files. So if we just go I for info and measure here to here, we are at 4.15 millimeters. So we are going to pull that out and see if we are 4.15 millimeters to there. Hey, we can just do this. Flat to flat, and we are at 3.69 right now. Just double check that. 3.69. So we need a little bit more. Now we're going to start pressing this gear on there. So I'm going to switch over to this. Hey, Ellen. So I need just a tiny bit. I'm going to go just kind of gauge by how much splines I have there. I'm just going to go that much more and see where we're at. .9, 4.15. I don't know how critical this is. Hey, Daniel. .17. 4, oh, 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 4.15, 4, 6, 5. There we go. 4.17 will be fine. I learned that from Quinn. Okay, the other one. So, get on like that. 2 microns is close enough. Yes. Okay, center there. It's on there. This guy. Sure everything is aligned. So what's the reason for switching the gears? Because the profile of this is designed to match up with the printed output shaft from the extruder stepper, because this has to change. For every tool change, this moves. Edge of catching that one on here. Oh, same place, about the same place we started last time. So let's go in here. Now when I measure this, I rock it onto that flat surface there to make sure that I'm perpendicular on there. And I actually went 4.26, so I went too far. Yep, cool. I don't want to move this too many times, but I am going to move it back just a hair. What should the tolerance be? I don't know. I want them to be the same between the... I think I want them to be the same. 4.13. I'm not going to keep moving this back and forth. If I feel like I need to change it again, just make sure that is rocked. Oh, yeah. I am more confident that it's rocked and it's exact. So, measure the gap while it's in the vise. Yeah, I could. I will. Okay, plus or minus 0. Good enough. Plus or minus 0 is perfect. Okay. Install the Bondtech drive gear onto the shaft in the below orientation. So, drive gear. Install, being sure to catch the flat spot. We will be loosely tightening the screw and omitting any Loctite. We'll finalize the gear's position a bit later. Okay. So let's grab this one and that grub screw that we go. Where'd you go? Oh, there's already one in there. Never mind. That's a... Oh! I dropped an M2 grub screw and I found it. Okay, so on one of these, this guy goes gear side out. Let's see, okay, there. Gear side out, and it looks like there's a very small gap, but we're gonna do a final adjustment on these later, so that will be good enough. I find those if I go barefoot in the garage. Yeah. That one, where is the kit I just opened? There it is. Sprinkle some nerds on the floor and call Nero. He is never going to live that down, is he? That will be the thing for all eternity. His entire streaming career will be about eating grub screws. Flake finish on those epoxy floor makes it so hard to find small parts when they fall. It does. It really does. Go. You will not, yeah. Okay. And then place that into the tool housing. Being sure that shaft properly engages the bearing we installed previously. And then we're going to slide an ideally straight length of filament through the entirety of the tool housing. Use the exposed length of the filament at the drive gear interface to position the height of the drive gear. Rotate the drive gear so that the set screw is exposed and tighten the set screw. We don't, I guess with the shaft bottomed out. Okay, so here, and this goes in here. Engages that. And then we throw, with the grub screw visible, throw a piece of filament, preferably straight. There are far worse things to be remembered for. This is very true. Okay. So that. So if we see the gear needs to come down just a little bit. It's a little far that way. So that's pretty good. Try to get straight on the camera, because when I look at it straight on, it's dead on, dead center. So that one is done. This one, you gotta get that you're past that spot, that tight spot. Same deal. It's a little off in about the same spot. There we go. It slides through a lot easier now too. Do I know how to set the jumpers for Octopus for the NEMA 17 motors, 24 volts? It depends on what stepper drivers you're using. Are they 2209s? Then follow the manual for UART. Okay. That is done. Now we're going to locate this part. We're going to put two heat sets, two of my heat sets. This is a small part where the slightly larger heat sets are not great. Slightly smaller ones would have been better, but I think it'll be okay. Okay. we have 2 heat sets to put in here. We have one in this top hole here and one in the side here. That's not too bad. My heat sets because I screwed it up. Okay. Point where I need to start wiring the printer. There's one. Does anyone know? That's the garage. These floors do get way too slippery when wet. I had them when I had this done when we first moved into the house. We had it done. We had this and these cabinets done. So it's basically we ordered the cabinets and they had an option for epoxy floors and they contracted that out. I had them do 2 coats of the clear over because I didn't want the texture to be as pronounced, which makes it even a little more slippery, but yeah. Okay, insert a 2mm dowel pin into the locating bore on there. Okay, 2mm dowel pin. Is that in the motion box still, or was that in the, that was in a weird box, right? Was it in the miscellaneous other? Or is that in a, it's not in here. Here. They're not in here. They're not in the individual things. Ah, 2mm by 6mm dowel pins. Okay. It was in the miscellaneous other box. It's not. It's in the, it was in the miscellaneous other box because we use these for the locating feature on the gantry somewhere. So we're going to grab 2 of these right now. I like these little test tubes. Bridge the left. Which pliers? Will these get large enough? No, I think just barely not. Well, yes, they will actually. They'll get large enough. I think that'll work. So I will use these to start it. Trident soon. Can't wait. Did you order a trident? When this is done, you'll have a great collection of tubes. I know. To figure out what to do with them. Okay, so I'm gonna try to just get it just in there enough to wedge it in, and then, oh, so close. Get it just a little bit more in. There we go. It stops right there. Okay. And the other one. I have split those several times. Split that part right there. There we go. Nice. 300 cube LDO. Nice. The next part you will see, I don't want to see. I see what you see. I see what you're saying. What is this? This doesn't actually hold it. It locates it, right? I don't think I have an M2. I don't think I have an M2 reamer. Don't think I have an M2 reamer, but I may have. Where did that go? May have just a 2mm drill bit. Okay, I'm gonna try that. Is this 2mm? This is 1.5. It's not 2mm. Do I have a 2mm drill bit? All right, just go for it. Biggest GitHub manual for 1.9 covers the jumper settings. Do you have a comparable Imperial drill bit? Yeah. Where did I put those? I don't think I have a 2mm reamer. What is that? What size is that? Actually, what? Oh, come on. I have a reamer in here that's awfully small that I've never pulled out of the packaging, apparently. There we go. Or is this a different set of reamers? That might be an M3. Let's find out. This might be M3. Yeah, that's an M3 reamer. Add 2mm reamer to the kit. I bought my reamer set before I knew that KB3D sold them. I just got a generic kit off of Amazon, and it did not have a 2mm, but I'm pretty sure the ones that Chris sells have a 2mm. I'm looking for my little numbered drill bit set. Where did I put those? That should have. Where is that thing? Oh, apparently I didn't bring it out here. What do I have? I have a let's go for it and see what happens. Or did I put it in here somewhere? Is it a YOLO? It might be. Where was the... I thought sure I still had my little numbered drill bit set out here. I guess I don't. What is this? What's this? We said is nifty. Those tiny cheap Phillips drivers from China are usually around 2mm. Yeah, that's 2.4 right there. That's a 2.5mm bit. That's not gonna work. Huh. Ooh, that's 1.95. Yeah. That right there is 1.95. Let's see what it looks like. That's going to be good enough. Yeah, this guy is going to go in however this goes in, what, like this? Yeah. And that just locates that on there. And there is no play there, so I think we're okay. Okay. Do you know where LDO boring kit tool set? I know, I was looking for that, Ryan. I had that in my mind of looking for a bit because I knew that those came with that. But anyway. Secure part 6 to part 3 using an M3 by 16 socket head. M3 by 16. Is that one of these that I had grabbed over here? Yep. One. And see? I remembered I put it in the hex tray. So this guy goes in here. Why isn't that just part of the main print? Printability. See, that prints on there, and that would be a major overhang. Yep. Ooh, careful. Okay. So that one and that. There we go. Not too many ugga-duggas there. There we go. It's time for me to see you, Lewis. And then in needle bearings, place the idler gear into the printed hinge, noting the below orientation. Capture idler with a 3 by 20 millimeter shaft. So we've got the shaft that comes with this 20 millimeter. It is. So that, and a little bit of grease. These are pre-oiled. I'm not going to redo it. And that's an actual oil. That's like it looks like a white lithium grease or something. I'm going to call that good. I'm not going to redo that. Okay, so we have that, and it goes into this guy. Now the problem is this prints like this, which means all those layer lines are going this way. So let's ream this out to make sure that that is not going to split. So where's my 3 millimeter reamer? Did I put it back over here, or did I keep it over there? It must be over here. Did I use the 3 millimeter reamer earlier? Where's the 3 millimeter reamer? Did I use it here earlier? There it is. There it is. Okay. So 3 millimeter reamer. We are going to very gently. I think I am going to use this in the drill, so I have more control over how straight it is. 4 millimeters in the drill. Actually, I'm going to go from the side that has more meat and go straight through. Yeah, see, it pushed that little bit of plastic right out. As long as it doesn't split, that's going to be okay, because it's not going to fall out of there. Which way does this go? This is like that. This goes like this. And this goes through. Just going to push this straight down. There we go. It barely captures over there, so we're going to push it a little past here. Oop, too much. There we go. That will be good. It is pretty minimal plastic right there, yep. This is in the direction that it's not pulling on that spot, I guess is one way to say it. This is going to go in here, go like that. So the other thing is we're going to ream that. Right, because that's another pin that's going to go in there. Yep. In 3x22. Okay. So we're going to do the same thing here. We're going to do the same thing over here. That one's done. Where's the M3x22 shaft? I'm guessing it's one of these. I need, let's put those in there. Those are different lengths. Which one is it? Must be that one. If I'm worried about 0.01 millimeters, there should be 5 though. Yeah, there's 5 different bags. That's one bag for a tool head. That's one bag for a tool head. Okay, so if this goes in here, then this is going to do that. Now I'm going to additionally ream out that, I think, because that's another, oh no, that's in the proper orientation, so I think I'm going to leave that tight. Yeah, this is just for one. I think I'm going to leave that tight because it should allow it to stay in there. Now that's interesting. Oh yeah, okay. This thing is just gonna, let's pull that out for a minute. So if I go there. This is never coming back out at this point. Does this use filament sensors in the heads? Ball bearings. Those are for the coupling. Gotta find the right adjustment here. The ball is for the kinematic coupling to the... Jeez. Okay. Ba-doo. Ba-doo, ba-doo, ba-doo. I feel like I probably should have reamed that out because this is really tight. I'm not going to be able to get that back out. I feel like I should have reamed out that other hole. How can I pull this out? Yeah, I'm not confident that that is going to stay. No, just broke it. Yep. I think, yep, I just broke it. Okay, so that one's going to be broken. I'm going to reprint. It's just this little piece here. No, it's this piece that broke. Pulling it out without scoring it is the challenge. Yeah. The smooth jaws on these pliers are pretty safe for that. But this guy right here is going to get reamed. And we will try that again. So this one needs to get assembled. This. And the longer of the two shafts. There. And this guy. See you, Josh. Stablebot build is calling. I was going to ask you how that was going. So, what material is it printed in? This is glass fiber ABS, which for this particular thing is not ideal because you're sacrificing that strength across layer lines. So that goes there, and we're going to come in from this side. Okay, just going to press just a little bit. Too far. Trying to just kind of sort of center it. There we go. Centered there. Hey, Brent May. Welcome. And then this is going to go on here, but that's the one that I just reamed, so we should be good. Much better. Just use the round of the screw head to make it a little under flush there, which centers it up more across it. Okay, that make sure that that was the one that, or at least is centered. Yep, it's centered. Okay. It's there. Then, I'm guessing one of these plates go on. So that goes there. Locate the printed part and insert the remaining into the pocket. Ensure the bearing is fully seated. And place 5x4 magnets into the shown locations. 5x4mm magnets. Magnet should rest against the printed stop ring, resulting in a below flush position. Okay, so then we've got this guy that needs a magnet or a bearing put in there. Bearing put in there from, that's weird. Grab one of these. We're gonna need 2 of those magnets. Stop before I do that. Why? What? The part that the tool dock round bits go through. The part that the tool dock round bits, is that what? Is that these guys? Is that what goes on here? Oh, I see. Oh, well, that's fun. That's fun. Apparently my grub screw didn't actually hold this one. Scroll down, yeah, ream those. That's weird. Apparently I didn't. There we are. Okay. I didn't. My little grub screws that hold these 4mm dowels in, I threaded them until I started getting resistance. And for some of those, that was not to the point of holding the dowel in. There we go. For about 3 of them. You want, so I need to ream those to 4mm. Did it say to do that? Locate the printed part. So I put that in and then place these magnets. The magnets should rest against a printed stop ring, resulting in a below flush position. Align and seat with the main 5mm shaft. Locate a CNC tool plate. Awesome. Okay. You want it to be smooth or maybe a little oversized. So that's what this is going to do. Oh. I didn't put any pressure on that. I just wanted to make sure any little goobers that were in there. There's a stop for the magnet too. Yeah. Yeah, that if you look in there, you can see a little lip. You can see a little lip down in here, and I can feel it with the screwdriver. In fact, I can make sure there's no filament or anything goobering that up. Okay, if I take this over here now and put this on, it does slide on and off with no effort here. Every tool board does, as long as I have it lined up. The end one is a little tighter than the others. Okay. Big step, that is a pain to fit in post. Got it. So now magnets need to go in here and they get pressed a little below flush. But we put this, where did I put this thing? Before I lose this, this guy goes in here. Do I have a flat enough thing to, let's do that. And it's a tool board for each tool. It has wiring for each tool. Not 100% sure what that looks like. What am I going to use to press that in? Since it's here, it's down here in a recess. Think of, oh, I know what I can use. That'll be easy enough. Say hex nut. I don't want to press in the bad spots on it. But as a hex, nah, I don't trust a hex nut. What can I use to press that in? What can I use to press that in? Oh. I'm going to use that. Use something in the kit. Sure I'm not there. Make sure I am over that. Because that should be nice and flat. Yep, that worked. Does this design utilize BQ's new multi-extruder expansion board? No. No, it doesn't utilize any of that. So that just barely fit in there. And then it's a flat surface to press against. Okay, so that is in there. That is turning. And the next thing is to press those magnets in. Must be these guys. 2 5x4. This is using the big board from Duet with an expander. So is there any need to pay attention to the position or the orientation of these? Okay, I don't think so, because it's just going against the ends of these of the dowels in there. So I'll just make sure that they are consistent. So I'm going to, right about there should be good. But the one on the tool itself and the aluminum is important. Okay. So this is going to go in there. And then I got an idea. I've got so many of these grub screws. Put that right there. Down, and I can feel right there. Right where the stop is in there. hopefully right where the stop is what we want. Okay, so that's in the proper location. Let's grab it there and push it in there. Now, how these aren't super tight on here. Hopefully these get pulled into the part. They don't get pushed out, so I think it'll be okay. So that is going against the dowel pin, and those are done. So then this guy goes on here, and it must go on this way. Matches. And oh, now we get a CNC tool plate. Woohoo! Waiting for one of these kits guys to put not to be taken internally, do not eat on that tag. Yeah. There they are. More CNC pretty goodness. Okay, we'll grab one of these. So, 2 bearings. According to this, we put 2 bearings in here. Loosely secure the tool plate with the main body. Oh, that goes that way, huh? Oh. Using M3x16 flatheads. Okay. So this and this and that. That must go like that. There we are. And that goes on there. Like that. And M3x16 flatheads. And 3x16 flat. Oh, that's in the tools bags, not the. That's gonna be in here. Okay, James. Can't wait to see the finished printer. After Rocky Mountain, my wife told me I needed to build a tool changer for Hue Forge prints. Perfect. So I've got some set screws, set screw. Here, M3x16. There we are. Put those in there. Hoping for a similar request, but alas, no. There should be 4 of those. Let's go there. Just kind of checking alignment of everything. See if everything is kind of lined up. These are those bearings that are going to rest against the plate. And now that I see that these are even, these aren't offset at all, I need to fix the tool plate. So now we locate the wedge plate and secure using M3x6 flathead. So wedge plate. I am getting lost in the things. Where's the wedge plate go? Oh, there's one. Wedge plate. Point of curiosity, your additional prints for heads, are you going to revert the heat set changes, or for symmetry, leave them as is to make a full same set? I'm going to revert them because I want to make sure that it's going to work right. So it's more important for me to test the changes that I make than the consistency in that. Like Poity said, this is the little wear item that locks the tool to the carriage with that little, with the NEMA 8 actuated rod. So, and this was borrowed from Jubilee. In 3x6 flatheads. I should have some here. That is these guys. Three by six. There's a wear item. Sort of usage are you getting from them? Replacements printable or ordered. These are little, what are they, HDPE or something super slick. Just a point of order. The M3 threads on these are pretty tight. They're there, but they're tight. It's hard to tell. It makes it harder to tell when you've tightened down enough on that plastic part. Cool. Then we got a Bondtech thumb screw and a temporarily remove the spring and small spring retention washer. Install the printed part against the side face of the thumb screw and reinstall the spring and tension washer. That's weird. Matthias. So. Officially out of packing supplies. Okay, so this guy goes on here. Should that go all the way on? So do I need a little reaming action? Imagine this goes back on. Loosely install the thumb screw through the latch and onto the heat set insert for the main tool body. Okay. And then we're going to locate that part and use an M3 tap on that. So this guy is going to go in here. Not sure what this is for. I guess that matches. And then we need one of these. And we are going to tap, tappy tap, tap. Where'd my tap handle go? Here it is. That little flag is cool. It's to hold the wires. Oh, okay. Holds the wires out of the way. And this guy right here is what gets tapped. Does that go all the way through? I wonder what it gets tapped for. Temporarily install an M3x6 set screw in this location for use later in the assembly. Okay. Just doing this not over the workbench. And 3x6 set screw. There's probably one in the tool head baggies. Remind me when I'm short one over here. That guy goes in there temporarily, I guess. Holds the piano wire. Okay. Is there's no hole that it's pushing against. Oh, is it pushing against? No? Huh. I don't know what it's pushing against. Okay. Fit the part 4 to the main body as shown. To the main body as shown. And secure using an M3. Is that this? Oh, that goes over. Was I supposed to have a heat set there? I think I was supposed to have a heat set there. That's what I was messing up on. I'm going back. I know a heat set needs to be there. I want to make sure I was told to put one there. Yep, right there. Oh, sorry. Right there. I missed that. What is... Oh, that was borrowed from over here. Hold on. I borrowed a grub screw and I didn't put it back. There we go. Let's turn this guy on and put a heat set in there. There is a hole. There is a hole? Where? I honestly don't see a hole. Maybe it's squished. Maybe it was a sacrifice to the first layer squish. This guy is going to go right here like this. Ah, and then around that. There's got to be a hole there. Let's look at that file. Is it this guy? No. Which part is that? It's not in order. There it is. It is. See that? That hole should be right there. And there's a hint of it. I can see now. There's a hint of it. Right? Oh, come on. Give me focus. See? Right there. There's a hint of it. Easy to look over. Where's that little 1.4 millimeter? Yep, a little 1.4 millimeter driver. Not supports. No supports were printed. It's just a little bit for a tiny piano wire. And I'm not going to drill this in. I'm just clearing the hole spot. Even then, maybe I'll clear it with the piano wire next. If you click View in the File Explorer and enable Preview, it will display the 3D model. Is that a Windows 11 thing or is that a Windows 10 thing? No preview available. Oops. No preview available. No preview available. View. Preview pane, details pane. Preview pane. No preview available. Okay, let's go back down where we were. What size screws were for this? It's both, but I think you need to install the STL thumbnail viewer for it to work. Got it. Fit part 4 to the main tool body as shown. Secure using an M3x8 flathead at the bottom and an M3x10. What is M3x10 in? So the M3x8 on one side. What's a 10 in? 3x8. STL viewer and GitHub. Okay. So this guy here, this guy goes on here, and then M3x8 in the red location. And M3x10 in the other location. There they are. What by default software is assigned for STL? Well, it's the 3D model viewer. Okay, I don't think these need to be all that tight. Just snug. Okay. 3D viewer is the you know what, those aren't necessarily even, are they? .9 millimeters. Oh no, they are 1.9. Okay. Yeah, that's a nice little setup. That's filament path. What is next? Locate CNC tool cooler block and orient as shown. So I should have some tool cooler blocks. CNC parts. I don't think they're in the CNC bags. I think this is a separate piece. Let me find these. These are the pieces for Zarivos. Do I have these yet? Yes, there they are. There they are. Oh. I'm gonna take the one that decided to be different. CE is Community Edition. So the 5 tool heads, what is the total cost of that kit? Yeah, just under 4,000, I think, is probably a good, with the Gucci options, all the things. This magnet does matter. Got it. Ooh, magnet. Do we get to play with epoxy? Okay, important. Magnet polarity matters. At least that's the first thing it says. Now I can ignore the rest, right? Because too many words. That's a good design to make on the Milo. I could. That is definitely a Milo capable part. On KP3D side in the order menu. It's very, yeah, apparently they're going to revise it. It's really really not user-friendly right now. Once installed, it's very difficult to remove this magnet without permanent damage to the tool cooler block. The shown face below at which we will be installing the magnet will ultimately face and interact with the tool dock. Hey, Dragonflame. The magnet must be installed so that it attracts the previously installed 5x10 magnets along the idle tool cooler bar. Shown below is a standard tool cooler for use with slide-in heat breaks, such as the Chimera Kraken. If you're using, yeah, we've got that covered. Press a 5x4 magnet into the bore shown in red and be sure the magnet is fully seated. Avoid the use of sharp objects or harsh blows to the magnet itself. For best success, consider warming the cooler block before inserting the magnet. This can be done for safe use of a small butane torch, or even setting the block on the printer plate. Running a test print on my Trident now after doing a dragon burner. You did not miss anything going boom. You missed chat going boom when I was talking about water cooling systems, but here, let's see if we can do this here. I'm gonna walk over here just as a view, and I'm going to place the magnet there. So now I know what polarity we're dealing with. And this is going to basically, does that actually fit on there? Yeah, right there. Can I start it pressed? Ooh, I can. Okay. I don't know if I should just press that in or if I should heat this up, because it seemed to start. I mean, it's pressing in there okay. It's nice, and it is not coming out. That is a Milo machine. I will machine that part out of Milo before that comes out. Yeah, that's done. That is very flush in there. It didn't need to. I decided that it didn't need to when it's stuck. It sticks to the other one. When it started just with pressure. It started just with pressure, but that's not coming out. That was a decent amount of pressure to put that in with the pliers. But yeah, that was good. It did say to heat for expansion, but only if it had trouble going in, right? For best success, consider warming the cooler block. It doesn't say we have to. Definition of a light press fit. Yeah, this is good. This will work fine. It is blind. It is a blind hole. Secure the tool cooler assembly loosely to the main tool body as shown. Yeah, it didn't, nothing cracked, nothing. It wasn't excessive force. I was about to heat it up if it was going to be more. Secure the tool changer assembly loosely to the main tool body as shown using two M3x18 button heads. M3x18 button heads. Back pressure isn't good for the press. Okay. It's not gonna, it's, I don't know. Don't know. So now this and this. So if that is oriented that, and that's oriented like that, this is going to go on here like this. Just makes it harder to press. Got it. Thank you. That makes sense. It was doable with the Knipex, so I'm figuring it's fine. So it said loosely, so we're gonna go loosely on these. So that's got some wiggle there. I imagine we probably want to thread a tool in there to make sure everything's lined up. Prepare a short length of Bowden tubing for use between the heat break and tool body. Now, the next note is what I was about to say. This is not applicable to Revo equipped tools. Insert the previous, and then, yeah, we're gonna basically thread a tool up into here too. So this uses no fan for the heat break, but makes use of, it is water cooled. So now that rotates, but it doesn't shift. Hey, I can see through the 0.4 millimeter hole in the end of the Revo. Don't need to do that. And then I guess once this is nice and even, these can be tightened. Tighten them alternately with some, making sure they are, let's do it on the bench here to kind of, what is that? Yeah, it's fine. Make sure it kind of stays square. Need to adjust it based on the dock tool head. I'll loosen them if I have to. Thread on the heater block using the image for a height reference. Yeah, that's not. Install the heater cartridge. The wires themselves should exit. Before proceeding, take time now to ensure the filament enters and exits the drive gears smoothly with no hangups. A properly assembled tool with a clean filament path will allow you to push a length of filament through the entire tool without snags or high resistance. Let's go ahead and grab a heater core. Did I move those? Yeah, there we are. Go. Then I guess this can come up here and sits behind that, just to kind of help keep it out of the way. I'll play with this bend here. Probably like that. But we take this guy. Can I get my finger in there to move it? Not really. So let's see, can I pull this? The only thing missing from the water block is a small ring for Revo spring retention. It has one. It has it. Yeah. It's right there. Come on. Come on. No, you want to focus here, not there. Yeah, see? I'm just seeing if, yep, there it goes. Filling right on through. Ooh. Okay, put this on. There we go. Okay, so filament goes through it just fine. You amount of tension on the latch arm may need to be adjusted. Filament enters and exits drive gear. You can rotate instead the 51 tooth gear through the drive gear with a finger. That's a small finger. I can barely get my pinky in there. Loosen again the M3x18s. Install a nozzle and torque against the heat brake. Okay, I did all that. So those being tightened are okay now. And then do not install any silicone boots at this time. I'm sorry. I can't help it. Time to drive 300 miles so I can be on time for work tomorrow. See ya, Joey. Have a good one. We are getting close to done. Oh, are we done? We're at the end. That was 7. Let's look at what 8 looks like. We're not going to continue on to 8. I don't have anything printed for 8, but this is electronics mounting. Nope, I don't have them saved there. I've got them. Guides. 8. So yeah, we've got lots of printed parts here. 7B, where's 7B? Was there a 7B? Oh, shoot. What in the world, Chris? What in the world? What did I miss? FDM tool alignment and adjustment. Oh, okay. So this is good. This is good. This is still a good stopping point. This is still a good stopping point because I don't know if you caught earlier, Chris, but I don't think I properly glued the parallel pins in the tool plate. I spent so much time because the fit was tight on the 3 side. Those are perfect. The 2 side, I didn't actually use my Knipex to push those down into the spot fully. So I think they cured just slightly too proud of the thing. But what we might be able to do is, why don't we just move this camera over because it's going to be easier on my back than moving this thing now. Let's see, right there. We can play around with how this thing sets on there. There we are. Oh, look at that. So these guys right here are too proud, and I need to pop those out and fix it. It's going to be a pain in the neck. Is there anything that dissolves epoxy and not aluminum? And then see, this is our little tool for docking and undocking. So we're going to start horizontal, and then this guy is going to go right on here. Oh yeah. And then I think, can we just turn this one way? Yeah. It's docked. Dynamite. Gotta run. See you, Bill. See you Tuesday. Have to finish mowing. See you, Tuxedo. Awesome. So that. So now if I turn it the other way, there we are. Pulls off, and then probably rotate my table. And then this guy, just pick one of these. We'll go here and rub against, there you go. Rub against the silicone there that are adjusted a little too high right now. Yeah, a little too high for the Revo. But without those there, let's see what this looks like. Actually, that can stay there. Oh, that's the one I need to fix anyway, that I'm missing the spacer. So if I do that, Go. Now this will go on. And that does, it's still a little high, but I think I can push that down a little bit more. The Revo, when it's docked, the tip of the nozzle doesn't rest on that silicone block. Should it, Chris? Short stream? It's 6 hours. This is the gray. That's that glass fiber ABS gray. You can attempt to roll with it like this. All that matters in kinematics is that the engagement is consistent, but I think I know you well enough that that's not going to happen. Guessing this machine aimed for around 90 to 150 millimeters per second. I don't know. What is the projected speed that this can go? Hey, Brian, is that dock retention mechanism similar to the E3D? I'm not super familiar with the E3D. It is very similar to the, and taken from the Jubilee, but that might take it in turn from E3D. I'm not sure. Anyway, this is cool. The magnet is hitting there. Only 6 hours. Now that goes on, if it's straight, it goes on without any binding. This one over here is a little tighter, and I'm not sure why, but we'll figure that out. This also might have been the one that was slightly looser. The rest of these go on without any problems there. But that silicone pad needs to be a little lower and a little further forward. But there is some room in here to play around with this printed part too. Multicolor speed benchy maybe. It was white or gray. It is gray. It is gray. Anyway, cool. One tool head is done, and that was the goal. That was my internal goal for today, was to get one of these done. Thanks for another wonderful stream. We'll be looking forward to your email. Awesome. Thanks, Art Chapman. See you, Joel. We are wrapping up. So yeah, this was good. We are on to part 8, which is installing electronics. So, and that's going to take a little bit, I think. What holes in the tool in the dock? There's a magnet on the bottom, and it physically releases from this part of the tool. So, see you, Jack. Thanks, Stu. Thank you to Pex Pepper, the hot sauce giveaway. Thanks, Polymaker, for the filament giveaway. Thanks, everyone. Gifted memberships, donations. Thanks for putting up with me with my frustrations with water cooling talk. Thank you, KP3D and Chris, for enabling another build. We will be back at this next Sunday. Tuesday, we are going to be working on the test station. It's sitting right there at the moment. So, good progress. With that, thank you, everyone. We will hopefully see you on Tuesday. Have a good rest of your week. Have a good rest of your weekend. And enjoy the build.